Welcome to APEC Open Mic. It's September 16th, and I'm your moderator, Tim Ventura. I want to give a big thank you to everybody for joining us on today's call, along with everybody watching us on YouTube. Just a reminder to everybody, tell your friends, tell the people that you work with, your colleagues, folks that you talk about with emerging propulsion and alternative science about the APEC conference. Our website is at altpropulsion.com. We're going to have replays there as well as on our YouTube channel. Again, please tell folks and get them involved. This is a community resource. This is your conference. And we put this all together with you in mind so that you can get the word out about what you're working on and hopefully learn from what others are working on as well. So today's session is all about open discussion and ad hoc presentations. We don't have anything scheduled in advance. We did have a couple of attendees who reached out and asked us if they could present. I am really excited about these guys. I want to start out with just kind of the quick reminders. So you can view conference replays, details, and speaker info on our website at altpropulsion.com. Again, you can also view replays of everything right on our YouTube channel, and you can get to that through the website at altpropulsion.com. During these ad hoc presentations, today I'm going to mute everybody out just to prevent interruptions. Please try and save any questions that you might have for after the presenters finish. The nice thing about open mic is, once they are done, we're going to have lots of discussion, as much as they are able to do or feel comfortable with. You can raise your hand in Zoom using Option Y on Mac or Alt Y on Windows. You can also type those questions into chat. We're not going to be firm on hand raising during open mic unless things get chaotic. So let me encourage you to jump in if and when it feels appropriate. Try to keep things focused on the core topics of our community. And, if we're doing Q&A on these presentations, please try and keep it focused on that. So today, we have Bryan Kelly. He's going to be doing a talk today called Light Pumping for Anti-Gravity and Inertial Mass Reduction Effect. He'll be introducing a novel and original concept for the development of alternative methods to optimize a propellantless approach to transmedium propulsion within the method of ambient light. So just a couple of words quickly about this. Jeremiah Popp actually introduced me to his work and said, you have to reach out to Bryan Kelly. You have to get him on APEC as soon as you possibly can. Right. And he was super excited and super adamant. And so Bryan actually sent me over a copy of an earlier talk he did, and I was blown away. He has so much information. Also today, Dave Rossi, who needs no introduction whatsoever, from Generation Z. He is going to be running us through a new experiment he's been working on featuring an electromagnet with a superconductor immersed in liquid nitrogen with a magnet above it in its Meissner state. Once the electromagnet is pulsed, the magnet disk go propagating, which indicate a direct charge expulsion from the core of the superconductor. So he's described this as basically a step up from the great work of Mr. Nasikas. We're going to start out with Dave Rossi. This is a really exciting demo. He sent this over to me, and I was really blown away. And you will be too when you see this thing. So let me start out with that. Let's go right to Dave Rossi today. And I am going to spotlight him for a moment. And I will ask him to unmute as well. Okay, there you go.
Perfect. Thank you, Tim. Sorry, I just needed your permission there. So, Tim, first off, let me just say on behalf of myself and everybody here, thank you so much for putting this together. Without you, this wouldn't be possible whatsoever. And to everyone else here, welcome. I'm very honored, as usual, to be here. The last time I presented was probably close to a year ago. And so what I'd like to be presenting today, I have some notes here I'm just going to read off of for a couple minutes, and then we'll get right to the video, is essentially Lorentz force propellantless reactionless thruster. And so, in essence, the thruster is propelled by nonlinear forces due to the effect of the magnetic field on the superconductor. As we know, superconductors expel magnetic field lines, and as a result, an external magnetic field source will exert a force on the superconductor, the so-called Meissner effect. The field lines are more concentrated within the center and or inertial axis of the superconductor, which push it in the convergence direction, whereas the field lines impacting the outer surface push it in the opposite direction, but those ones are much weaker. Now, the net effect is that the superconductor has a net propulsion force in whichever direction one arranges or points the setup in. Now, we know, for example, that Dr. Nasikas, who I very humbly stand on the shoulders of in this case, attempted this in the past with, to my knowledge, varying success. And so this is an attempt to provide an alternative, we could say, solution to such. Now, before I showcase the video, let me just say that there is also the possibility of RF and acoustic excitation and induction with combination in combination with what you're about to see that breed some very compelling results and observations, but that will not be the focus of today's presentation. Today is just to show the basic proof of concept situation that we have here. So let me go ahead and showcase for all of you what we are looking at, because I don't think for this audience we need any more explanation. And so before I play it, I'm just going to explain the layout here. And so very simply, what we have is an electromagnet, and we simply have an aluminum bowl on top of it, like an aluminum bowl, like a popcorn bowl from your kitchen, with a superconductor inside of it that is immersed in liquid nitrogen. And a magnet is placed atop it, atop the superconductor, in which it is in its respective Meissner state. Now, the aluminum bowl is also connected to a high voltage DC generator. And then the high voltage DC generator is also connected to an electrode to increase the, we could say, the voltage and therefore the potential. And so what I'm going to simply do is play it for you guys, and you will see that the voltage initially creates the potential, and then we run some current into the bowl. But the key is the pulsing of the electromagnet. Once the electromagnet is pulsed, you will see a very strong propagation force. So we see again, it stands on the shoulders of Dr. Nasikas in this regard, and I'll play it one more time. A very eloquent and simple setup. So there's nothing inside the bowl other than the superconductor itself. And that's essentially my presentation. Very simple, very to the point. And I want to thank Tim essentially for having me. And if anyone would like to reach out, whether it's via email or some other way, I'm very happy to discuss this. This is essentially based off of the principle by Saxel and Woodward many decades ago, which was when they took a cylindrical aluminum sphere and electrically charged it and rotated it, the cylinder would begin to essentially lose its weight. Now, I'm not claiming what we are seeing here is weight reduction, not at all, but it is essentially based on the principle of curving space-time in a non-linear form. So that's essentially about it, and I would like to thank Tim for having me.
Awesome. Dave, that's all you have?
It's very simple, very
okay.
to the point. Then there's a lot that we can go into the details, but I don't want to take away from.
Well, why don't we take a few minutes? You know, if anybody has any questions, let's do that. Okay. And I'm going to allow participants to unmute themselves. And yeah, I don't want to go too long before we get to Bryan, but yeah, let's do some Q&A. And then, you know, Dave, if you're still here later, we can go into in depth more. So yeah, anybody, it's Alt Y in Windows, Option Y on Mac, or you can put those into chat. I would say if you have any questions for Dave, just raise your hand. Mike Liloff. Go for it, Mike.
Hey, Dave. How you doing? My name's Mike. What was that? I'm sure you already described that. You have a rod sticking out top of the electromagnet. What is that doing? Just sending the arc over to the dish?
That's just an electrode to provide potential voltage to the bowl itself.
Is it connected to one end of your electromagnet coil?
No, it's just connected to a high voltage DC generator that's completely separate. from the electromagnet. The electromagnet is the final stage in all of it. The electromagnet is the last thing to be turned on. The second the electromagnet gets plugged into the wall, that effect happens. And I saw someone in the chat ask if I have a slow motion video. I do. I also have videos with RF and acoustic, but that's a whole other range of conversation that I'll probably have to come back for because there's so much there.
Gotcha.
Awesome. Awesome. Okay. Well, thanks, Mike. And let me see. I believe Curtis Horn had a question briefly. He raised his hand.
Oh, sure. Can I play the slow motion video? Sure. It's
Oh yeah, go for it.
Yeah, sure. It's a bit of a close up with 1 second here. 1 second. It's this one here. Okay. So this one is a lot slower and it's very quick, the effect. And this occurs right when the electromagnet is plugged into the wall. There's no gimmicks, nothing inside the bowl other than the superconductor with a fairly heavy neodymium magnet on top of it.
Are you pulsing the electromagnet, or is it?
It's what yes, essentially yes.
Okay, and Curtis had asked about the slow motion video. Sorry, I was having problems with my chat window there.
Oh, gotcha. No problem. Hopefully that helps, Curtis. Again, like I said, if anyone wants to reach out, I have quite a bit more of this. I've been sitting on this for a little while and decided to, with a silent partner, to go public with it. So yeah.
Dave, it's awesome. Thank you so much for bringing, and thank you for coming as well. You know, I mean, all of you guys, again, I keep saying this, you guys think I'm crazy. This is your guys' conference. So thank you. Right?
If I could say one last thing, Tim, the attempt here with this particular experiment was to try and make it as repeatable as possible for everybody here. And it's similar to the Aronoff-Bohm effect, because I want to ensure that people can see it for themselves. In their basements, in their houses, and what have you. And what I can tell you is that for those interested, for example, in the mechanism of all of this, it essentially has to do with what we could say is the curving of space-time electrically, an asymmetry, if you will, that is induced, that creates a charge expulsion.
Yeah, that is awesome, man. That is awesome. Okay, well, we're at 4:12. I think we only had that one. Yeah, we only had that one question then. So why don't we do this? Why don't we go, if it's okay, we'll go to Bryan Kelly. And Dave, if you're still with us later, I would love to have you talk more about it or anything along those lines.
I'll stick around. And the reason is just because I have my own theories on all of this, and I don't mean to. I'll be much more open about it after Bryan's presentation, if you guys would like. I just don't mean to hog the spotlight.
No, you're doing great, man. You're doing great. And thank you again. Okay. Well, you know what? Before we do that, I want to briefly, we haven't been clapping enough. Everybody, please put your hands together.
Thank you.
Dave, Generation Z, the man with the demo today.
Thank you. I appreciate that very much. I'm looking forward to Bryan's presentation now that you brought up what the topic is about. So
yeah, well, let me do that then. So I'm going to ask Bryan to unmute. And I'm going to spotlight Bryan for everyone, and I will mute everybody else out.
And I will share screen, which is over here. So you can see that's okay. Doesn't matter if you see it. All right. I guess everyone can hear me. Hello, everyone. I am Bryan Kelly, a retired engineer and attorney with a background in design, construction, startup, and testing, as well as legal issues within the energy, engineering, and construction industries. I also worked in surety and fidelity bonding, including white-collar matters similar to the Bernie Madoff case, like the one I had with Jeffrey Epstein's mentor, in addition to construction cases at large financial institutions like Citigroup and AIG. The details of my background can be found on the links page I just put in the chat, along with a link to the page I am reading from right now. The subject today is called Light Pumping for an Anti-Gravity and Inertial Mass Reduction Effect. This is a concept of mine that is about 10 years old now. I am giving you a bare bones introduction today because as you can see from the links page, I've got a lot to say and many different ways to say it. So this is just a brief and concise overview. You can read the detailed links and watch the videos posted there at your convenience. Now to the overall concept and general principles. Most importantly, I start with the assumption that light, the full spectrum, is the best medium for us to use to cause an anti-gravity inertial mass reduction effect at this point, and not space-time. Light is in space-time, but it is not space-time itself. I am not dealing with space-time, the vacuum, quantum foam, or anything like that. The relevant medium for this concept is also not air, and it is not water, and it is not even space itself, which is mostly just filled with light, but of course has other things in it. The way I see it, air, water, and space are not things that have light within them so much as they are things that are within light. So, light only, and by that I mean the full spectrum, is the medium here. Secondly, and very simply put, to achieve an anti-gravity and inertial mass reduction effect within this medium, we will mimic the phases of matter, which are in turn caused by energy levels, which are in turn caused by light. So we can use light to move through light by pulling it through the skins and bodies of a massive object, which will simultaneously cause the desired anti-gravity and inertial mass reduction effects. There's much more to it, of course, but again, this is a bare bones overview. So I can start with this falsifiable statement, one of the first things I dared to post on Twitter back in 2016, quote, "Light pumped through matter reduces the effect of gravity," unquote. That still holds true today, of course, as contradiction of that statement would effectively amount to nullifying the phases of matter, which may be possible as there is sometimes the oddball exception, but I've never heard of that exception. We can put forth such a general rule because we know that the phases of matter are caused by their energy levels. That is, light moving in, through, out, and around, commonly referred to as absorbed and emitted. I added around to those concepts as an object or craft encased in a bubble of slippery light is going to provide us with mitigated friction, drag, and inertia, in addition to the anti-gravity effect. We will be within things like air, water, and space, but always slightly separated and not interacting directly. This bubble notion is not unlike the warp drive bubble concepts, as some of you may have already surmised. These light bubbles can then be intensified, diminished, and shaped to facilitate relative motion with respect to other objects. So we will simply mimic the as yet unfalsified natural phenomenon described as the phases of matter. That phenomenon also generally describes what buoyancy is and the lift of gases. Solids and liquids typically don't lift, despite being comprised of the very same atoms and molecules. But gases do, because of the light pumping in, through, out, and around the molecules and atoms. We will simply harness and scale this well-understood effect. Waveguides and the like can also be made to cause the same outcome with the desired anti-gravity like floating and inertial mass reduction effects. We all see this phenomenon constantly, but for the most part, don't appreciate it. It is easily observable in natural archetypes, such as when observing the differences between water ice, liquid water, and water clouds, as well as with man-made airships and balloons, and probably to a lesser extent with butterflies, insects, and birds, a slightly more speculative sidetrack that I am avoiding today. because I am only addressing the bare bones. To keep it short, sweet, and hopefully effective, I am sticking to the mostly indisputable today. To debunk what I am suggesting here will take you straight back to the phases of matter themselves and how energy levels work, as well as things like basic buoyancy. Then one would have to explain away how the archetypes mentioned above exist somehow, in spite of the effect of energy levels, which are in turn caused by light. Then they would have to explain why these archetypes cannot be mimicked and improved upon drastically, especially given modern material sciences and optomechanical knowledge, because that is precisely what I am now proposing. It took me a while to do it, but the arguments for this concept are now pretty much bulletproof, and new methods to improve upon these natural processes are flowing out of the science and engineering community every single day. Buoyancy, lift, and the phases of matter are material properties that human beings can certainly improve upon and optimize. There is absolutely no reason why they cannot be utilized more effectively and improved upon drastically. Yet this seemingly obvious endeavor has not been undertaken. This unfortunate state of things is also why the concept and the general principles I present to you today are not patentable or otherwise able to be monopolized. They belong to everybody. But what is done is one thing, and how it is done is quite another. So what I am saying is that the open source anti-gravity and inertial mass reduction process is right in your face. I am telling you in plain language exactly what that is. It is not 0-point energy, but it is free energy. So I propose that we take this free energy and perfect the light matter interaction in order to bend it to our will, as was done with fire and the motive power of heat in general, and which we can now extend to the entire spectrum. It is time to move beyond that narrow band of infrared upon which we so heavily rely. That is what science and engineering are for. This is how human beings progress. So, this is where the metamaterials come in. For example, the lift of the random hydrogen gas molecules in, say, the Hindenburg, every single one functioning haphazardly and working against each other could be ordered and purposed and vectored right down to the angstrom level. That is, optimized with metamaterials. Molecular and atomic approaches, waveguides, photonic crystals, topological insulators, plasmonics, quasi-crystals, sub-wavelength waveguides, and maybe even some mythological, magical isotope tweaking will all likely work. But these metamaterial design and fabrication efforts must be working toward a feasible, intelligible, indisputable, unfalsified general principle. And light pumping is indeed such a principle. If we also happen to bend space-time or warp the vacuum by accident along the way to this idiot-proof sure thing, then so be it. Stranger things have happened. But in the meantime, we are going to use those metamaterials and waveguides to capture and transfer the explosive momentum of ambient mass equivalent light. You can call it a continuous radiation pressure or even thrust from reloadable fuel until you get comfortable with the idea. But just keep on thinking about those angstrom-sized atoms or sub-wavelength waveguides capturing and exploding photons thousands of times larger than they are in the nanometers, and how fast they can be made to do so. Also, internalize and understand the fact that the very medium you will be pumping through is also a highly efficient propellant when used correctly. Did you hear me back there, Skunk Works? Or shall I repeat that? Anyway, this is how you do propellantless, at least for the time being. We are talking about angstrom-sized nanopumps and picometer waveguide systems that are hardwired by nature to run and keep running at attosecond light speeds and higher. That's 18 zeros per second every second since the Big Bang. It is not quite perpetual motion, but those numbers will work out fine for most of us. Per square inch, those angstroms are in the quadrillions by area and the quintillions by volume, or thereabouts. That is 15 more zeros by area, working with those 18 zero attoseconds in an already lighter than air metamaterial, such as graphene, which is simply hydrogenated graphene, which is simply graphene soaked in hydrogen. These materials can fuse those nanopumps into a solid chunk of a skin, comprised of automatically refueling nanorockets in the octillions, all acting as one. This kind of design will start to approach optimal energy densities, which will then be compounded with femtosecond and attosecond time scales to produce paradigm shifting efficiency. Things like that will give you radiant flux per mass density in abundance, petajoules and zetawatts, and are becoming achievable here and now. There are many, many ways to look at this concept, mostly all describing the same thing. From Newton and forces to Einstein's description of the mass equivalence of light, to floating iridescent hummingbirds, to tales of the UAPs themselves, allegedly. That is why there is a link to the links above, and why this presentation has to be short and sweet and packed with things like falsifiable but unfalsified statements, indisputable statements, and mind-numbingly large, small and fast numbers until people get the general idea of what I am talking about. Then we can get into all the subtleties, which certainly do exist, but are not dispositive of the overall undeniable efficacy here. So basically, I am all but telling you the way it is, not suggesting it. Nature is what it is. That's the way it is, and it has been here the whole time. The science is already there, going back to at least the Greeks anyway, and almost certainly further. The math seems to be lagging right now, though, just as it was for the Montgolfier brothers, the Wright brothers, and the early Chinese rocket scientists. As with them, the equations will have to play catch up here, as usual. Sometimes we lose sight of the fact that physical concepts and ideas exist independently of the many eccentric ways to explain them. That said, I will go on to suggest that equations around supercavitating bubbles in fluids within variable gravitational fields might be one way to describe this. Or it might be done with optomechanical force studies for light matter interactions in a gravitational field. But right now, there is not even a consensus on photon mass for thrust, despite photons being the drivers of most of it, or barely even the notion of fields of light in air or water where the force of gravity within is diminished that I have ever seen. Nor have I ever seen a model for a point of mass deterministically controlling its own light bubble in a gravitational field. Perhaps something like that exists, or should exist, for supercavitating hypersonics and submarines, but I doubt it. Is such a region of curved space less curved than that instance? Are the tensors and cones any different under such conditions? Are the gravitons no longer as coherently aligned? I happen to think so, but that is inconsequential, because I don't think anyone has ever thought about some of these things mathematically. Why would they? But again, right now, as far as I am concerned, that is their problem, not ours. I don't know why this scenario isn't already on paper, and barely care right now. I am here to float away at will and shoot off at the speed of light in my own cozy little light bubble, using the absolutely obvious characteristics of nature. How that is documented later is of secondary importance. But despite my apparent hubris, I will be glad to help with the bookkeeping. Please just spell my name correctly. I would also like to ask somebody more mathematically proficient than myself to explain how the mass of a light entangling, and by entangling, I mean in the plain meaning of the word, not the spooky action with Alice and Bob sense. How the mass of a light entangling object over time, losing its mass equivalence at a rate greater than the local gravitational field's acceleration requires, may be likened to a snapshot of negative mass. I would think there might be some math already done out there by now, but I tend to doubt it. Or perhaps we can update the rocket equation, make it continuous, put the rocket in a mitigated gravitational field of its own making, and wrap a slippery light bubble around it to reduce drag, friction, and inertial mass. How do we rewrite F equals ma for a body in motion when a major component of that body is not mass, but mass equivalence? The thing with this is, this concept can be described 6 ways to Sunday and back. But apparently, since that hasn't been done conclusively to date, this novel concept, which is simply mimicking what already exists in nature, will have to bring that about. So, yes, the current lack of comprehensive mathematical descriptions is a weakness here. But that is not an obstacle, merely a historical footnote, because the phases stand unfalsified and archetypes exist. The notion of optimization, which would involve the engineering of metamaterials in this case, has proven worthwhile over and over again throughout history, and this concept is fresh, fertile ground. You can see all of this with your own eyes, whether you appreciate it yet or not. That the math is once again lagging innovation is merely a secondary concern. It often does. Not always, but often. Fortunately, that gives other people something to do. One upside to this weakness is it will also cause people to realize that although this concept has yet to be described mathematically to everyone's satisfaction, including my own, it is also impossible to debunk mathematically, because nature is what it is, no matter what has or has not been written or published about it. And while sufficient archetypes already exist, this concept is indeed testable as well. I started experimenting with balloons and mirrors early on and did it for years. But for this crowd, a basic metamaterial might be necessary, starting with perhaps a homemade street corner bootleg graphene or equivalent. Think of it this way. All you will be doing is taking something lighter than air like graphene and making it even lighter than air by adding hydrogen to it for a hydrogenated graphene known as graphene. Then you gradually learn to control its inertia mitigating anti-gravity properties. You dope it to turn left. You decorate it to turn right. Whatever it takes. Then you start building around it. Instead of a mirror deterministically reflecting the sun onto a balloon, maybe Mark Sokol chasing a piece of street graphene through the back alleys of North Jersey with Jeremiah's magic wand might be the stunt that finally opens the world's eyes. Or as I suggested to certain well-known TTSA members repeatedly on Twitter years ago, put the material in a chamber and just fiddle around with the different electromagnetic fields, temperatures, visible light, microwaves, X-rays, radio waves, sound, or whatever frequencies you have handy to see what affects and controls it. Ultimately, we will build around these malleable material properties of lift and buoyancy, which are caused by light, and optimize them until we are pumping light at a rate approaching the speed of light. It may seem very silly and funny for a while with the magic wand, like it was for me in the balloons, but ultimately, this cannot not work. I'll say that again, this time for Raytheon and DOE in the back. Ultimately, this cannot not work. At some point, it is just simple common sense. But I realize and acknowledge that a few performative hoops may be desirable here. But no, it is not as awe-inspiring as warp drive. But bulletproof and idiot-proof will just have to do for now. So, take a quick look later at what I call the Philly Flyer, linked right here on the page, for an idea of what that might look like at first. Maybe before we get the magic wand out, something along these lines might inspire the experimentalists. But we can talk about all that stuff later. This is a bare bones overview and is not intended to be a deep dive into waveguide and metamaterial technology. Okay, getting away from the prototypes and back to the archetypes. I would expound for just a moment on the UAPs and UFOs themselves. I have personally never seen one, but we have all heard the stories, and people familiar to us all claim to have seen the compelling data. I tend to generally believe these accounts because they describe multispectral signatures and light pumping behavior that is precisely as I would expect them to be. with the so-called glowing auras of cold light. To me, the 5 observables should be called the 5 utterly predictables. I have a web page on precisely that topic, in fact, but since we are bare bones here today and that is a huge distraction, I will say nothing further about it now. You can find that link later and read it to see why I occasionally cannot help but scoff at Aero and ATIP and TTSA and all the infotainment, limited hangout, slow roller types. The UAPs are, in all likelihood, pumping the full spectrum of light within a medium of light, just like a Virginia-class submarine pumps water, but doing so far more efficiently. I don't expect anybody listening right now to buy that line wholesale, except the ones that already do but won't say so. But at some point, I predict that all of you will see that this stuff could not be more obvious. As for inertia, inertia means very little when your craft's surfaces are not directly touching atmospheres, be they gaseous or liquid, but are instead encased in a nice slippery light bubble. There's a bit more to it, in my opinion, but that gets into spin 2 gravitons and why spin 1 photons cut right through them, which is the kind of thing I am skipping in this bare bones overview. Similarly, gravity means little to nothing to mass when the mass is losing mass equivalence at a rate greater than the local gravitational field's acceleration requires. In space, you would just aim the thing at the nearest star and start pulling light through the mass and pumping it back out at a rate approaching the speed of light. The craft will be pulling and pumping light in, through, out, and around while maintaining its own little protective and slippery bubble or cavity. I got $10 that says that is what most of these alleged UFOs and so-called unidentified anomalous phenomena are doing. But we will just have to wait and see. Okay, so the bottom line here is that this stuff is actually simple and idiot-proof. It boils down to a recognition of the need to optimize an analog of the phases of matter for a certain purpose, commonly called buoyancy, or perhaps now anti-gravity. Human beings have been changing material properties since before the cave was invented. So why stop now? This milestone, anti-gravity and inertial mass reduction, is one that we have not yet fully addressed with even the most basic tools and easiest concepts at our disposal, but only with notions that, while ambitious, are not yet feasible. So let's just admit that much, get over the embarrassment of letting the accomplishments of the Montgolfier brothers and their progenitors languish, and get on with it. Building around the inertial and gravitational mitigation properties of the light-matter interaction is a natural step. It just got waylaid for a while in favor of force and thrust. Instead of using brute force explosions to overcome gravity, we will use the benefit of higher energy levels to free ourselves from gravity and inertia in a more subtle, elegant, and effective manner. This approach involves harnessing and using ambient energy in real time and is not unlike solar power in that respect. Make no mistake, this is the hard tech play of the century waiting to happen, folks, if I do say so myself. And I won't even mention the green energy aspect of it because I shouldn't have to. I may seem a little underwhelmed about this sometimes, but I am fully aware of those facts and just a little bit fatigued by them. The free energy is all around us, in every photon, right down to the visible light and temperature in the environment wherever you may be enjoying this presentation. This free energy includes the entire terahertz spectrum, by the way, which is another distraction I'll save for later. But all that is the temperature range found everywhere in the universe between negative 459 and positive 334 degrees Fahrenheit. So if you want anti-gravity, inertial mass reduction, and free energy, first realize that you are in fact sitting in it. I am here to tell you how to capture it and use it. To quote myself, if I may, quote, large numbers of little things doing little things quickly and repeatedly add up to very big things, unquote. In this case, the underappreciated scales and numbers in nature are far more relevant to solving this problem than our equations, at least for right now. And we will be using time as a tool here, letting things just do what they do naturally at the very high speeds they do them at. When you set things up to do what they would be doing anyway, but so that they are doing them optimally for a purpose, that is how words like propellantless and perpetual motion leave the fiction and fantasy realm to become real life. There are zeros upon zeros of bulletproof, idiot-proof, octo-quadrillion, zepto-quintillions just sitting out there, waiting to be used. Those tiny little things in such large numbers and such high speeds and in such small spaces compound and add up. As anyone who has ever worked around nuclear energy, as I have, can tell you. So, there is no excuse why anti-gravity inertial mass reduction cannot be achieved. Starting now with us. The technologies are already out there, but they are unguided, unpurposed, ignored, forgotten, and or underpurposed. I am here to get the ball rolling in the right direction by first focusing people on intelligible, feasible, and achievable concepts, and then developing them. When you are stuck with a difficult situation in life, so that you have to repeatedly reframe a problem, and it seems to be going nowhere, sometimes you will stumble upon a much easier solution than the ones you have been trying over and over and over again to no avail. Sometimes it can be shockingly simple, as anyone who has ever tried unplugging it and then plugging it back in can attest. this is one of those times. Normally, I would call myself a simpleton here and joke about how it takes a simpleton to find the simplest solution. But not this time. Instead, once again, I will assert that this light pumping concept is the way to go now to make the most progress in the least time with the knowledge and resources we already have. People should keep working on the warp drives, gravity generation, and quantum inertia, and whatever else. But again, I would assert that this almost mindless, overlooked simplicity is undoubtedly the best path to pursue vigorously, and that is just the base reality for now. And it can only succeed. Period. This outcome will happen eventually anyway, with or without us, here and now. But why not us? And why not now? Got something better to do? At the risk of sounding defensive, the logic behind this concept cannot be seriously questioned. The physics is already there. Anyone can see it. With the energy levels and phases, it is what it is. So you can either accept that and start working toward the future or not. The math is mostly there, and things become pretty obvious when considering the undeniable effectiveness and the possibilities of cascading scales of time and photonic momentum. This reality is almost indisputable, despite the fact that the concept is perhaps lacking its best and most concise description with mathematical symbols. Perhaps ironically, the engineering and fabrication technologies are both further along than those aspects, because there are people unknowingly doing bits and pieces of this work all around the world right now in academic laboratories and fledgling industries. The basic materials for a lot of this are already out there, but their use has not been correctly purposed, let alone optimized. It is up to us in this tinfoil hat affinity group to start to make that happen. In closing, I realize that I may not have explained this to everyone's liking as yet, and that is understandable. On the other hand, there's very little chance that this notion can fail. One way or another, it'll happen eventually anyway, even if it is only a step toward bigger and better things. So now it is your turn out there. I will gladly take questions now or anytime on X, formerly known as Twitter, or in my YouTube and Rumble channel comments, where other people might benefit from our interaction. Additionally, I plan on doing more shows like this, perhaps joining a few subject matter groups, and further expanding my small YouTube and Rumble channels until all of this becomes painfully obvious. After 10 years, I consistently bore myself by thinking about this too much, as it can get repetitive and tedious. But I never get tired of discussing it, and the future is wide open. In the meantime, thank you very much for this opportunity to speak, Jeremy, Tim, Bernie. I'm ready for questions, but first, I'm going to take a breath and drink some coffee. Thank you.
Okay, I am going to put this bad boy on gallery view. Everybody, please give an enormous hand to Mr. Bryan Kelly. Sir, that was like a poem almost.
Yeah, it was a performance piece.
That was awesome. That was awesome.
Well, it turned into a speech more than a presentation, but it's supposed to, maybe be a
I know.
pep talk, maybe a
I was thinking
cry.
to myself, I was waiting for 7 years ago to make an appearance, but
it was in there. It was in there. It was buried under zetawatts and petajoules. By the way, I really don't talk like Winston Churchill or Ronald Reagan or the Batman or the Joker. But yeah, I just kept on doing it over and over again. I started spicing it up to amuse myself and not be monotone.
Yeah. Well, no, Bryan, I think it was wonderful. I think you raised a lot of really great points, and I think that the delivery of it was really unique. Again, it was it was a speech, but it was also poetic, right? And
yeah,
it was interesting to see
over the top. It might have been over the top. I was going to warn you guys ahead of time, but then I thought, well, it's better to make excuses afterwards if it was too bombastic, because I'm yelling parts of it, to be honest.
Oh, no, it's well, yeah. And the mic captured that well, but
I'm sorry about that to anybody's eardrums.
But the better to ask for forgiveness than permission. That's basically our conference right here.
That was my last minute decision.
Well, so let me go to questions. Let me see. Let me go to Mike Liloff quickly, and then Michael Boyd. And actually, while you were delivering that, I have a bunch of news items that I want to get to. But let me go, Liloff. Let me go to Michael Boyd first. Mike.
Hi, Mike.
Oh, Mr. Boyd.
Okay,
there he is. There we go.
You said Mike Liloff first. You can go first.
Yeah.
I wanted to. I have this patent that I worked on, which it shows the optical pumping effect that Bryan's talking about. So I'd like to share that. But Mike can go first. If that's okay.
Okay. Well, yeah. If Mike Liloff had a quick, Mr. Liloff, did you have anything? He put his hand down actually at the last minute, so maybe he didn't have anything.
I was just going to ask about the graphene. What does Bryan know about the graphene?
Well, it's graphene, which is one layer of carbon, a six hexagonal, and on all 6 points of carbon you can place a hydrogen atom. So think of that energy density. That's how do you get better than a reloadable hydrocarbon? But it's, instead of throwing the baby out with the bathwater, you just take the thrust from the photons alone. I can refer you. I don't have it handy to put in the chat right now, but the government, I guess a couple of years ago, they commissioned a study on graphene. I call it the Bible of graphene, and I'm no expert on it, but there's a lot of information in there. It's difficult to find something that absorbs and emits light, other than hydrogen itself or something like that. It's perfectly efficient for what I'm talking about, and as we know, graphene can be, has a lot of great properties to transfer control of this proposed reaction, and it's tactile, it's brittle. I mean, it's not brittle. You can do a lot with it. Everything under the sun. I think it's Gesundheit. I think it's a good place to start. It was just an idea I threw out there. I have a little chunk of it, but frankly, I'm too chicken to mess around with hydrogen. At least I'm not that desperate yet, but I know these guys in the labs here, they're fearless. And, it's just an idea I threw out there. I think it would be a good starting point for anybody that's interested.
Awesome. Well, let me, if it's okay, let me go to John Brandenburg really quick. And I should mention, so John Brandenburg, he emailed me. He has a couple of things he wants to talk about later, but John, go for it, sir.
Yeah. Okay. Hey, Brian, huzzah, huzzah,
Yes, sir. Hey,
huzzah.
when I'm gonna tell you something you're gonna like. You want to hear it first? Or do you
Sure, I
want
don't have my tinfoil hat on, but that's okay.
No.
It stops microwaves,
Believe me, I know.
I
Yeah.
heard that it focuses them. I heard that it
Does
makes
a
it
lot
worse.
of things.
know.
Well, yeah, I remember Tim watching. I swear it was you back in the early days of the internet, playing around with those lifters.
Yeah.
I remember
Yeah.
that. I'm like, always been watching this show for a while, and I'm like, yeah, I do remember that. But anyway, I wanted to tell John Brandenburg, which this is
Tell me.
Yeah, I'll tell you. I'm doing research on this for over 10 years, and it's a long story. I won't
Sure.
too many details.
You're heading in the
But
right direction, though.
Yeah, I'm thinking I'm losing my mind here. This is dumb.
Hey, that shows you're getting close to the truth.
Well, here's where you come in. I'm digging around. I'm not finding anything. Then I find something because I was hooked on radiation pressure. That was my buzzword.
Absolutely. Radiation.
And I found a
flux.
quote from a real physicist, name of John Brandenburg. I found that quote, and
I'll tell him when I see him.
He says this guy says, because I'm not on the inside. I'm not like you guys. I have my education. You have yours. You're in the industry.
I'm not on the inside.
Well, you were.
I'm just doing my job, Mike.
Yeah,
Brian.
Okay, but I read this thing, and they were asking you about about what you thought of what these could be. What a theoretical propulsion. I don't know what the search term was, but you said it could have something to do with radiation pressure. I don't know. And I saw that. I'm like, this guy is he's thinking along, it kept me going. And here you are now. That's pretty amazing, because I have a web page I wrote for myself. It's not online, but it kept, just to keep a record of how I came up with this and all that stuff. And you're in there. You're a big
Well, I'm
player in
honored.
there.
Thank
Yeah,
you.
no,
I'm just doing my job. Just doing my job.
Well, thank you.
Yeah. Well, and John, thank you. And Brian, thank you again for presenting. Let me go to Honey Radiance next. There we go. Okay. Go for it, sir. Oops. Let me ask you to unmute.
Can you hear me?
Yeah, now we can hear you.
How is the audio?
Good.
It's good.
It's good.
Oh, good. It's my first time using Zoom. I've been listening to Alien Scientists for an APEC for years, and but I have never gone online to a meeting.
Well, now you're stuck. Now that you've unveiled yourself, now you have to participate.
Has anyone heard of
me if you want, Tim?
I wanted to ask, has anyone heard of Robert Distinti? Can you hear me?
I have not heard
I can
of
hear
him.
you.
You have?
No, I don't think so. Unless I saw his name in print, it doesn't ring a bell.
Oh, I wanted to. He's a physicist online.
Turn on the Barbie.
Okay, he's a physicist online who does.
Turn on the Barbie. You're gonna take the chicken out in 10 minutes.
All right. He's a physicist who has a blog called Ethereal Mechanics, and which he talks about the gravity as being a form of electric induction, a hidden form of self-induction, and I just, I've been following him for a couple of years as well, and so I think it'd be great to have him on the APEC conference and see how his physics meshes with Jack Sarfati's and
do you think you could maybe use the website for him and email him over, or that's the best, just the APEC website form, or like tim@altpropulsion.com. I think that's tim@altpropulsion.com will work. If you could email his info over, I'll reach out and try and get him on for you.
Okay, all right. Well, yeah, I'll try that out then.
Okay.
All right.
Yeah, well, and thank you for finally coming on, and welcome, long belated welcome. So
it's great to meet you all.
Yeah, absolutely. Well, this is the first of many encounters, sir. So now, again, once you come forward, now you have to participate, and we'll have more of your ideas. But definitely, email me the tim@altpropulsion.com, or just use the website form. That'll work. Either way, I'll get that, and I will reach out and try and get him involved again, either in an open mic where we can kind of go back and forth about it, or like one of the structured presentations. But we're booked out like 3 months in advance now on those. So that's why, like, that was why when Bryan appeared, I was like, Bryan, come this weekend, because the other one is like, we're waiting so long that, I forgot what's scheduled.
Yeah,
That's fine.
No, I'm a
Okay.
science fiction writer. And so I'm interested in, how to get to Alpha Centauri.
Yeah. Well, no, that's wonderful. That's wonderful. Well, let me see. Let me go to Wayne really quick, and then I'll go to Michael Boyd, because Michael Boyd had something he wanted to show us. So let me go to Wayne really quick, sir.
Okay.
Wayne. There we go. Hey, Wayne. Oh, you're breaking up a little bit. There we go.
Nice to see everybody here. Lots of great minds. Okay. Yeah, nice to see everybody here. Lots of great minds. And Bryan, nice to see you again. And I was wondering if you mentioned your experiment with the balloons.
Yeah, I briefly mentioned it. Yeah, it was in there. How could I not mention that? I was fooling around with those for a couple of years when I lived in sunny Georgia.
Yeah, that's. Yeah, because before we met, I took a helium balloon and shone a heat lamp on it and measured the difference in lift to about a 20% increase in lift, just from shining the heat lamp on it for 10 seconds or something like that. So I was pretty impressed by that. And then I heard what you said about the balloons too, and I'm like, I'm not the only crazy guy doing this. So
no, well, if you think about what you were doing with that, you're changing that material property to become more buoyant, for lack of a better word, to pump more light. Now, if that was, that heat source was on board, so to speak, you'd be completely propellantless. But we're still in the caveman age here with this stuff. But when you go through the process of what that is actually doing, you're freeing that balloon, that piece of plastic, from gravity.
Yeah. Because the helium or hydrogen atoms they're absorbing the energy at their specific wavelengths.
Yes.
That those molecules can store it, and then that's. I'm gonna ask some of the physicists in here to explain this, but the way I see it is, that's the way the molecules store the energy. It's altering the space-time volume, or the volume of space-time in which those molecules are, which changes how it interacts in the local gravity. That's how I explain it. But other people just look at it and they say that's just buoyancy. And I released a number of videos a few months back, just some of the experiments I did. And most people, they just thought it was buoyancy, but I showed that the numbers don't work to explain that. Because you have to displace a certain amount of volume of air, air to account for the measured weight loss.
When you dig into what is, the next argument from there is like, well, no, it's density. Buoyancy is caused by density. Okay, what causes density? I mean, you could take a lone hydrogen atom, put it in an airplane hangar, and it's going to be all by itself and not very dense. But if the thing is frozen, because there's not enough light going in, through, out, and around. And by light, we mean the full spectrum. I know I'm repeating myself. Then, you know, density isn't the answer. You got to manipulate that thing to make it work. Set it up so it's just doing what it wants to do. Put it in the right environment, which I'm doing with the mirrors and the balloons, and you did with the heat lamp, and the Montgolfier brothers did it. And there were airships in this country and this world for a while, and they're going to be again. But they're going to be efficient because we're going to take only buoyancy. Oh, that's just buoyancy. Has it been optimized? No one's ever thought has thought about it since, you know? Okay. Yeah, I know. You're on the right path with that.
Okay. Well, so yeah, let me see. Wayne, thank you. Let me go back to Michael Boyd if it's okay. And
Yeah, that's
Wayne,
fine.
thank you, man.
Okay.
And then Michael, you had something you want to do as a screen share. If you could do that
Yeah, I'm
briefly.
just going to show you this patent I worked on that shows just what you're talking about. Back in 1992, you can see my name there last. Can you guys see that?
Yes.
Okay, so now I'm going to take you down to this. So now what I did is I used to work for Hughes Aircraft.
Zoom in a little.
Can I zoom in? How do I zoom in? Like,
Control, scroll
is
up.
that better?
Yeah, that
Yeah.
should be good.
There you go.
Okay. So I made these infrared detectors, and this is a cross section of one. And it's, the semiconductor is called indium antimonide. And so this is the N layer, and then there's a P implant layer, and it was an optical infrared sensor. It had what's called a cutoff wavelength of 5.3 micrometers. So near infrared's like 1 micrometer. So now what they did is there's this layer, this insulator layer that we make, and what it is, it's glass. Okay, so we have the wafer here, and we're going to grow an oxide on it. And so what we do is we're depositing basically silicon dioxide is glass, and glass like you have in your window, it's totally amorphic. It's kind of like a real slow flowing liquid, which means it has dangling bonds. The crystal that is called silicon dioxide, and that's in a crystal form. And so when they grow this stuff on the surface of this semiconductor material to create the insulator and form the glass, it's not a very good insulator because it has all those little dangling bonds, they're called. They're little vacancies and stuff in it. You don't see them in the glass because they're too tiny. So what we discovered is we took basically a heat lamp, and we exposed the solution, the electrolysis solution that we were using. We exposed it to light. In this case, it's a slide projector. And then what it did is let's see if I can rotate this. Yeah, one more. There we go. So you can see here that without the normal anodic oxide, the normal oxide, it's these layers here, okay? And you can see the resistance. You can measure resistance by basically calculating the slope here, the current versus the voltage. And you can see here that after we exposed it to the light, it made it a better insulator. And so what I think is going on is when it's just like a solution being deposited onto this through an electrolysis process, it's like the electrons in the material aren't oriented. You follow? They're kind of like all pointing in a jumble. But when you shine the light on it, it's like a broad spectrum of light, and we shine the light on it. It causes all the atoms to line up a certain way, and when they do that, they become more crystalline. You follow? And so this is an example of what happens with the optical pumping, and so that's why I wanted to show it to you. And that's, geez.
It makes sense. Light would polarize things.
So,
Awesome.
so it's an example of how. Now, I don't see why that wouldn't work in. Why does it have to be in a crystal? Follow? It could be like in a liquid. It could be in a vapor state. I would think it would behave the same way. I mean, the distances and the time constants would all be changed, obviously, but essentially the properties should transfer between mediums. Follow what I'm saying? So optical pumping is something real that we've known about for a few decades. So I think you're on the right track. Short answer.
Good. I hope
Awesome.
you're right.
Awesome. No, that's wonderful. Michael, thank you. Thank you. And I think that was the last hand there. And Michael, so, why don't we do this if it's okay? Because actually I'm getting swarmed by people who want to present today. Let me put this thing back on gallery view. Everybody, one more hand for Mr. Bryan Kelly, as well as the wonderful folks asking intelligent questions today. You guys are busy, busy, busy. I had no idea that it would be this packed. So, so what I want to do now, actually, again, during these presentations, I just had one come in from Curtis Horn. He said he had a 3-slide presentation. I'm wondering if we could do that. Curtis, are you with us still?
I'm right
there
here.
There we go. Yeah. Curtis, would you like to do that? And then John Brandenburg has some stuff as well, but why don't you go ahead and do the brief presentation? How long do you think it might be?
I'm guessing like, let's see. I'll try to keep it short, like 15 minutes, 20 minutes, something like that.
Perfect. Yeah. I mean, even half an hour is good. So, go
Okay.
for it. Okay. Well, let me mute everybody out then, and I will mute myself.
You guys can see my screen. All right. So, okay, let's see here. There we go. So just a brief intro on my background. So I've been someone that studied physics since my undergrad. I actually started out as a music major, and I quit that because I found physics to be easier, much less time invested. But yeah, so I went to Rensselaer up in New York and did my bachelor's there. Eventually, after I did that, I worked for a while, and I eventually did a master's in physics. I wanted to go to grad school, but it was I really didn't find a program that I liked. So I did that, and after my master's in physics at Fullerton, I went to UC Merced, and I was working on non-imaging optics with Roland Winston and doing some general relativity work. I quit that to join a nuclear cleanup startup in 2011 after Fukushima happened. And the whole time, when I did my graduate work, I was a control systems engineer and practicing in a lot of different fields. So currently where I'm at is I'm helping Jim in the lab at Fullerton. He's in his 80s now, and he really can't keep going in there. It's really tough. So I've been doing that since October 2021, off and on. I also am working on my own startup in non-imaging optics applications in space. I had a SBIR proposal to NSF that got approved, but I didn't do the full proposal yet. I'm still working on that, finishing that up. I'm also had my own reasons why I was interested in Jim's work, which when I was an undergrad, actually I found this theory when I was an undergraduate at Rensselaer. there was a fellow by the name of Mendel Sachs who had a I would just call it a quaternion formulation of general relativity. It turns out to be much more than that, but so that was one of the motivators for me is seeing that Jim had something that was following the Mach effect, which I was thinking is the right approach, and following Einstein and Sachs's approaches. That was what had me interested. And over the years, I would always go and I don't know if you guys know Hal Fern, but Hal Fern was actually my advisor at Cal State Fullerton when I did my master's, and so I would go in every now and then and talk to Hal about how they're doing. And Hal's recently retired, so that's where that's at. So just to the next slide, I'll go over an update, a lab update, and it's more of an update from my point of view. And a lot of things I'm going to say are not, these are my opinions. Okay, so I don't work for Cal State Fullerton. I don't work for Jim. I'm volunteering and helping him with this. So I started basically in October 2021. I started going into the lab. At that time I stopped working full time as a controls engineer. When I started with Hal and Jim, they were doing the lab in the air, doing the experiment in the air, and they had a pendulum that was hung from the ceiling, and basically you could see when it turned on, you could see the thing actually swinging. So it was very impressive, but I had reservations about doing this, and this is something that if anybody's trying to replicate this experiment, and you guys are out there working on this and you're doing this in the air, you need to be very, very cautious, because the fact that we're using ultrasonic energy and you're able to do things with air, I mean it's gonna move it. So we actually that was a big concern for me, and it took a few months, and finally Jim put on some baffles and the effect went away. Okay, so the reasoning that I was given is that when the system was in the vacuum, they actually reran the experiment in the vacuum, and they filled the chamber with air, reran the experiment, they were getting the same results. So they were under the impression that meant that the air was not able to do anything or didn't make a difference. But it turned out what ended up happening is once you got out of the vacuum, the optimizations that would happen and the frequencies you would look for, getting larger forces, right? That was the goal, and the forces were larger, but it turned out to be effects due to the air. So now the drive is back in the vacuum. We've been working diligently, especially this last part of the summer, to getting the vacuum as low as possible. So before, there was only one pump, a Welch 1402, that would bring it down to, let's say, a few millitorr. That wasn't low enough. If you guys are interested in this and understanding the Reynolds number, there's a lot of interesting engineering that goes into it. But basically, even if there's a little bit of air, right? And NASA proved this with they actually have a helicopter on Mars, right? So even with a little bit of air, you can get some thrust. So right now we're working. We have a turbo pump in series, and we're working on getting the vacuum as low as we can. So that's something that actively, I was in the lab yesterday, moving big lead bricks and getting that stuff going. The other thing I still have concern with is that the nonlinear nature of the experiment. So if you guys are familiar with the drive, it's actually a piezoelectric stack sandwiched in between two pieces of metal. One is a brass mass, and the other is an aluminum kind of plate. And so it's non-symmetric. And when we're applying a voltage and a signal, that signal is in the order of tens of hertz. So you get the piezoelectric expanding, contracting very, very quickly. So it's a very nonlinear motion. So if you guys are familiar with acceleration and velocity, right? first, second derivatives of motion, you can get higher order. You might call them accelerations. They're called jerk, snack, crapple, and pop. Some of you guys in the aerospace might be familiar with those terms. So they're like the fourth, fifth, sixth derivative of motion. So we don't know how high it goes, but what I've noticed is that, you know, we will have like a quick movement, and it's very hard to characterize. And when there's nonlinearity, I get concerned when you're in a support. Right now we have a support that could be affected by that. So I have a concern with that, the way the experiment's being done. And the other thing in the lab is we plan to build drive with multiple materials. So right now, like I said, it's brass. So I'm hoping to use, and brass, I mean, it's a very, very similar density as steel and other things, but I'm hoping to be able to have tungsten on one side and maybe titanium on the other side where the aluminum is, because it's similar in terms of like the weight, but it's stronger. So we want to kind of explore also having, right now we have a stack with 16. I was thinking like, you know, we can have an 8 stack, a 32 stack, get as high as possible. And that increases the density. So there's an argument to say that the higher density we go, the more force we'll see. So we want to explore that. Let's see. Yep, there we go. So basically the next part here, I just wanted to put some discussion items or just throw stuff out there about, you know, where we are. I did just speak about the snack, crapple, and pop. So one of the things I'm looking for or trying to figure out is, you know, how high of a speed camera do we need? You know, like I said, these things we're putting in, you know, 30 hertz or something. So I don't know if we need a camera that can see the motion of the piezoelectric as it contracts and expands. I think taken seriously is important, and if we have really good footage and we can see what's happening, that might go a long way. Another thing is, I'm thinking that it would be good if we could have experiment in a linear bushing where the drive is actually just pushing in one direction. So that would also kind of go, because right now it you know, it's in a sort of a vertical pendulum that will go back and forth. Okay, so there's a lot of Newtonian arguments that can be made that, okay, there's nonlinear motion, and so, you know, that's expected, and there's no new physics there or nothing exotic happening. So we'd like to be able to have an experiment that is a reference experiment that people can recreate, that shows it clearly. So one of the problems with the linear bushing is we want to do that in a vacuum. So these bushings need to be magnets or something. I'm not really sure. Most bushings are, you know, have ball bearings, and that introduces its own problem. So, you know, because there's friction there and other things, and the nonlinear motion could, you know, the vibrations that could propagate could be an issue. So this is not a very easy thing to solve. In terms of the theory side, like I mentioned earlier, I had my own investigation that I'm doing in terms of quaternion general relativity and what the process is that's happening here. And I'm not sure if you guys are familiar with the Brett-Wheeler process, but that's a process that is actually, I have the wiki page open on this. So if you guys are interested in looking it up, you can find it on Wikipedia. But basically, it's describing a mechanism for making matter out of energy. So the classic way we're taught is you get two, you know, gamma rays, they hit each other, you get electron, positron. But another way you can do it, you can make this is in an energy field, a laser field, you get one gamma ray, right? There's no second gamma ray here, and all of a sudden they pop out, right? So it's called a nonlinear Brett-Wheeler process. So what I've been lately looking at is things like linear and things like this effect could be, you know, potentially linked to that process, where we're a lot of the similar elements are there. So that's something I'm investigating. And in terms of the Quaternion GR, I'm actually looking for a trying to figure out a computer algebra system like Mathematica. I was also looking at SymPy, which is a Python-based system. Something that will help out with the computation, because anyone that's done any serious GR knows when you're having to do a computation, it's like pages and pages of drudgery doing. So I don't want to get too much into it, but if you're going to do some serious work, it does help having a computer algebra system to check your work and get, make sure you're not doing like, leaving out terms or whatever it is. The other thing with the theory, I'm looking for collaborators. So I've reached out to a few people that that have done quaternion type physics, they're people are pretty busy, so I haven't found anyone that really has enough time to help out. But if anyone out there is interested and has the chops, or even if you're somebody that knows computation, right, in terms of like the Mathematica or the SymPy or Python, that'd be helpful as well. And then the other thing we are needing to figure out how to do funding. So I don't know if there's groups out there. I just got introduced to Tim because Jim and I were talking about this. But if there's anyone out there that has a group where you guys are like maybe doing your own YouTube channel or whatever you're doing to monetize or fundraise, I could use advice on what to do. Like I said earlier, I had a 20-year career as a controls engineer, so I never needed to worry about that stuff. Right now, because we, Jim had already had 2 phases of funding from NASA. Getting the 3rd phase is really difficult, right? So you have to have something that's replicatable and very clear. And I think we're still working towards that. So, yeah, any advice, anything like that would be good. And what I'll do is I'll put my email in the chat, and you guys can reach out to me. Any questions?
Awesome, Curtis, you are the man. Okay, so let me do this. If it's okay, let me stop your share real quick.
Sure.
And oops, sorry. Okay, Zoom is not perfect. When people enter the room, everything shifts around. You know what? Let me put this thing on gallery view. Everybody, please give Mr. Curtis Horn an enormous hand. Curtis, thank you. That was completely impromptu also. Which brings up the question of the whole, we started the APEC open mic. It's kind of come as you are, right? And part of that was because scheduling was so hard back when we were doing them every 2 weeks for that full APEC conference. Scheduling was so hard. And now it feels like, I don't know. It comes and it goes though, right? And as you guys well know, some days we would have days where like nobody had anything new to present. And then other days like today, it's like everybody has amazing stuff. So I think that we're on the right track. I think we're doing everything okay. Let me go to Mr. John Brandenburg, who had a question.
Oh, Curtis, thank you for your presentation, and please give my very best regards to Jim Woodward. I had the honor of working with him for a while and to try and get it, improve his experiments. And I just did what I was told. And we moved things ahead. But anyway, so with that said. And once again, please give him my fond regards. But this one process, the nonlinear, basically scattering of electrons out of the vacuum with high energy laser, is that a what you call a photon scattering process? Like you're scattering off a virtual photon in the vacuum?
I would suggest that the nonlinear is a little bit different. And if you look at that wiki page, it describes it, and it kind of, and it starts to sound like nonsense, but
yeah, I'd never heard of it before.
Yeah, right. They talk about you know, in quantum electrodynamics, right? Where's quantum electrodynamics? Why didn't this predict it? Well, you know, if anyone that's done a quantum field theory will tell you, it's one of those things where you're just kind of like mindlessly computing. Why are you going that way? Why is it? Why am I canceling this one out? Renormalization, right? Why do I have this procedure? And it's almost like after the fact, they're like saying, "Oh yeah, we were able to compute this." And so, if you look at the quaternion stuff, the stuff Mendel Sachs did, and what
Yeah.
I don't know if Tim and I are talking about maybe presenting in
I had
in
heard of
October.
that
Yeah,
work by
okay.
Sachs.
Okay, so I'm going to be giving in October as part of what I'm presenting an overview of that stuff. And,
Oh, good, very good.
And why
Will that be here
it's
on the APEC forum or someplace else?
yeah, Tim was talking to me about presenting.
Oh, okay, very good.
Yeah,
very
yeah.
good.
Sorry.
I don't know if it's set yet, but
yeah, I think we're looking at October 28th. And again,
Yeah.
we're scheduled way out there. So, you know, but
Sure.
that's awesome, right? It's better to have too much than not enough.
Yeah.
Always
so
better,
so
yes.
I'll tell you the reason why I'm looking at that, one of the reasons is and I'll just tell you why. So in Sachs's theory, one of the consequences when he does his work, when he looks at the electron, it turns out that when in that theory, when you take an electron and a positron and you know they come together, they don't annihilate to the extent where the mass converts to energy and they're gone. What they end up doing is they couple, and so they're a tightly coupled pair.
Oh,
And that tightly coupled pair, when it's hit with the right energy, it decouples in that theory. Okay.
oh,
And then, and in as a consequence of that, though, what Sachs postulates is a dense gas of these pairs that he calls the background pair. And when you have such a dense gas, you
yes.
can actually calculate the mass of the electron from first principles.
Oh, interesting.
So I'm not saying 100%. I'm sure he's right, but I always found it very interesting that, you know, here's this guy that had, you know, he calculated the mass of an electron, and I would go around asking
Well,
people,
everyone knows
where
from
else can you-
QED that the mass of the electron is infinite.
right?
One of them weighs more than the rest of the universe. I mean,
Right.
you know, one thing I learned taking quantum mechanics, I'm a plasma physicist. So one of the things I learned from quantum mechanics, taught by just a really great guy named Abe Goldberg, unfortunately passed on. He looked like a learned old rabbi. And he said, Brandenburg, you got to learn there's certain questions you can ask in this class and certain questions you can't ask.
Yep.
Yes, sir.
Yep.
Yes, Dr.
Yep.
Goldberg.
Yep. That's
You want
right.
to get finish your PhD and get out of here, you're going to have to quit asking certain questions and only ask certain questions that are allowed. And because quantum mechanics is just full of skeletons and closets, it's a haunted house. And,
Yeah. So just at a high level, I'll tell you what Sachs did is if you look at GR, like the equations
Right.
of general relativity, you get basically you have ds squared, right? And so it's not really factorized. So what you could kind of at a high level say that Sachs did is he took the equations of general relativity, and just like you can take the Klein-Gordon equation, factorize it, you get the Dirac equation.
yes.
He did that same procedure with the Einstein equation.
How interesting.
And there's a factorized set of equations that it turns out to be quaternions. Okay. And if you take those quaternions, if you're familiar with conjugation in complex numbers, so you take those quaternion equations and you add the conjugates, you end up with the Einstein field equations. And if you subtract the conjugates, you end up with the Maxwell field equations. So it's a sort of
I would like to look at this.
It's a sort of sidestep unification.
Sure.
Because the fields are conjugated and they're different, right? And the other thing he did is he took the Dirac equation and basically fully made it covariant with general relativity. Well, that formulation, the quaternion formulation, general relativity.
Mm-hmm.
So until you get quaternions, you can't merge the two. But then there it is. So when he took that, that's where that formulation of the Dirac equation that's more generalized, right, to be fully covariant. That's where he was able to get a difference in the prediction of what electrons do.
Interesting.
So yeah, I'll have a full.
I will
it'll
look
take
into
some time
this.
to do it, but I'll have a
I
full
will.
presentation.
I will tell you, I barely understand complex numbers. The situation is complex. Now, if you add, then if you say, oh, there's a step beyond that, that's quaternions.
Right.
But the quaternions are nice. I know, I understand, how they're used, and it's very, very good. They're a masterpiece of mathematics.
I sometimes wonder that whole vector quaternion war is what sent us in the wrong direction. So
are you questioning the results of the Great War? The wrong side won?
Yeah.
Like the Cold War or something? Yeah, I know what you mean. I know what you mean. But it is what it is sometimes,
Yeah.
So,
I think part of it was we chose what was easy to do, what people could figure out, right? So it's not really a statement on physics; it's a statement on people. Like, okay, well, we can. Well,
everybody understood what arrows do, and vectors that came pretty.
Yeah.
There was a long tradition of what arrows can do and what not, and that so that translated very easily into people a kind of intuitive understanding of vectors. The quaternions, beautiful as they are, what I heard is, oh, you can understand quaternions really well if you understand spinors. And I said, well, explain to me spinors. We're in an elevator together. Explain to me the spinor, what that is in 3 minutes. And the guy says, I'm not going to do that. You have to go study it yourself.
That's right. So yeah, I look forward to giving that presentation, and like I said, I want to keep doing this. Otherwise, the thing is, I haven't been working for a couple years, so I'm like running out of steam. So it's either get back to work or figure out how to get
monetize
this
research you're doing. Yeah.
So any advice?
Hey, there's a lot of that going around, Curtis. Believe me.
I know.
I know. I'm working.
And the wolves are at the door. I get called all the time. Hey, come back to work. And so, yeah, it's
well.
I gotta.
Remember William Shatner? Somebody asked him how did he, do his career, and become so successful, and he says, "I answered the phone." Some guy tried to plan their careers very carefully, like Marlon Brando, or something like that. He says, "No, I just answered the phone."
Well, and now he is apparently sending his DNA to the moon. That's his new thing.
Good for him.
Yeah, William Shatner space crystals. They put your DNA
along
into a
with
crystal.
Lieutenant Uhura's, whom I wrote a spoof on Journey to Babel once, and I had Uhura and Captain Kirk getting together in the off hours.
Okay, no, too much.
Anyway, on and on.
This is family rated.
This is family rated. Yes.
Well, guys, let me jump in if it's okay. And we're only
keep up the good work, Curtis.
Well, John, thank you. So, actually,
Yes.
Let me do this. Does anybody else have questions for Curtis? And if not, I have a couple of things I want to show you. And then John had some stuff to present as well.
Right.
Okay, well, let's you know what? Here, let me do this then. Let me put this back on gallery view. Again, one more big applause for Curtis. Thank you, sir. I sincerely appreciate your presenting. I mean, again, no preparation there. Yeah, Jim Woodward sent him our way, and I'm really excited to have him. I'm really excited to have
Good old
just
Jim.
folks participating. So I guess there are a couple of things I wanted to tell you guys about. One of the things that I'm excited about is we're recruiting for APEC, right? We're increasing our audience. Our mailing list is well over 2,000 people right now. Not everybody shows up.
Tim.
Thanks, John. And then one of the other things that I've noticed
You're
is
the fer de lance, the head of the spear.
well, my hope is that we can get as many people involved as possible.
Yes.
Statistically speaking, most of those folks are probably not going to be vocal or talk much, but they'll still be participating. And that's what's important. We're opening minds. We're getting people interested and involved. And it's kind of, it's like come as you are, learn what you can, and maybe you can implement that. And, maybe it just becomes a seed for future growth. So that's exciting. The other thing that's exciting, this is a technological thing. I've noticed this with our interviews. YouTube is going through and doing speech recognition on a lot of this stuff, and it's kind of slow going. I don't expect to see anything major from this in the next few years, but I have an interview channels that I do. And what I found with the interviews is they go through and automatically put breakpoints into the videos so you can jump right into key aspects of the topics. And I believe APEC videos are the same way. So when these go up online, they're actually being like basically what would you call it, chapterized, I guess. And I think that is absolutely wonderful because in the future, I'm guessing that those chapters will be searchable. And even if it's not on YouTube, again, on our website at Alt Propulsion, we split them up like that. So, overall, I mean, we're creating this massive body of content, and it is searchable, and you can find different parts of it. I used to do these as playlists, which was incredibly difficult. Now what I do is put chapters in. That's something that YouTube, they open that up to the average person probably about a year into the conference. And so over time, everything that we're generating will become more and more visible and useful and searchable. And that's wonderful. So it's not just the people who are here. It's not just people who are fans of this. My hope is that everything that we're doing can become resources for people who are doing research as well. So if it's okay, before we get John on, I did want to showcase a couple of quick things. Let me do a screen share for you guys. Okay. And here, I'll start with this. And I will drop links in where I can. Okay. So the first thing is, in case you guys missed this, NASA released their UAP independent study. Let me see. And it's not showing it. Hold on. Let me share that one more time. There we go. Okay. Sorry about that. NASA released their UAP independent study results this week. This is a big report. I've gone through it twice. This, in terms of government reports, this is incredibly well written, but probably not in a good way. I've gone through this twice, and every time I finish reading it, I have zero takeaways. I guess one thing I did like is NASA is saying that UAP are unknown, and that we should celebrate the unknown, and that's part of the spirit of the human imagination. That's about all I got out of it. Yeah, so it's I believe the word that some have called it.
You better mute me. I'm just.
Oh yeah, okay. Let me mute you for a minute, John. I'm not going to call it nothing burger. I will leave that for other people to use that word. But what I would say is, for me, this is very much like John Wick Part 3. It's the kind of movie that you watch several times because you've forgotten you've watched it. So, it's one of those movies where you're like, you know what? I don't even remember seeing this, but then it turns out you have. So that is out there. I'm going to drop this into, I'll drop this.
Was it worth the money they spent on it, you think?
Probably not.
Okay.
but if they put that money into Artemis, they still wouldn't reach the moon, right? So why not? So there's that. Then the other thing, and I will scroll through this. I will also upload this in just a moment. I'll upload this into chat. Salvatore Pais reached out to me about a week ago. He has a paper called Superforce, the Fundamental Force of Unification. And he said, in fact, what did I can read you what he said. He said, Tim, I hope everything is going well. I need a big favor. Please send the attached paper to everyone you know, especially Dr. John Brandenburg and the APEC contingent. He said, equation 1 is extremely important. It can be used to show the superforce can make the proton act as a black hole. It can be used to show the reason for cohesion of matter, as well as the reason why the proton would take a long time to decay if it decays at all. So he said it is very important. I believe he's talking about this equation right here. I'll just highlight that. So again, I'm going to upload this PDF into chat for you. Sal sent this to me. From what I understand, he sent this to a few other people. Again, he is just for the brief overview. He is not in hiding, but he did change jobs a couple of years ago. And the group that he works for now just doesn't want the publicity. So they've asked him to tone things down. We are working on trying to schedule an interview. I'm going to try and get him to elaborate on this. He doesn't like having his contact info or anything like that shared, but he did send this out. So I will upload this for you guys. And I will scroll through it just so that it's recorded in our video feed as well. So you can see page 2 is the force of unification. Page 3 is finding the superforce in the Schrodinger and Dirac equations. And page 3 there has engineering the superforce with a brief conclusion. So there's not a ton to this, but that's probably good because we have so many lengthy papers come our way. The other thing, and I believe he's here with us today, is Mr. Glenn Tony Robertson of superconductor fame and long-term NASA fame and the STAFE conference and his many other things he's participated in. Apparently was just awarded a United States patent. And if Tony's still with us later, I will get into this. He sent this to me actually during the conference. It's a method for creating a rapidly changing energy shell of quantum fluctuations about masses for acceleration without mass ejection. So I can't believe I just read that on the fly. See, I do too much science stuff. So that's what I have today. But without any further ado, let me do this. I want to upload this paper for you guys in PDF format. And our very own Dr. John Brandenburg actually has 2 separate PowerPoints that I think he wanted to share. And if he has trouble, I can do those for him as well. So let me stop my share and I will go to Mr. Brandenburg when I find him in Zoom. There he is. Okay. John, go for it, sir. Oh, and you're still muted, sir.
Oh, how am I doing
there
now?
You go. Perfect. And do you want to do screen share when you wait for your PDFs?
Actually, why don't you just do them? I'm just so I don't have to
Okay.
multitask.
Tell me when. Just tell me when.
Yeah, just let's start with the comment on Salvatore Pais's Superforce. Let's start with that.
Okay, and I'm just uploading Superforce now. That is in chat, so just so anybody knows, you can click to open, and there should be a way to download that as well. And let me open yours, John. It is on my desktop.
Okay. I'll get better at this.
No, you know what? No worries. No worries.
I'm trying to understand spinners right now. It's got my mind completely twisted around, you know.
Okay, and oops, sorry. See, and now I'm having trouble with it. Well, okay, I can put it up. Can't remember how to do slideshow on it, but
okay, let me see if I can do a share screen.
Oh, do you want to? Okay.
Let me try this thing. And Okay. Okay. Ooh, right. Okay. Okay.
You know, I can put it up. I just can't do slideshow because it takes over my screen.
Oh no. Okay.
But that's fine. Here, let me do a screen share and I'll put it up like this.
Okay.
There we
Thank
go.
you. I'm sorry. I'm not very you see hear what my two youngest kids tell me about my technological skills. I said, well, I'm only a rocket scientist, you know. But anyway, so I'm going to first comment on Salvatore Pais' very fascinating theory. And please, next slide. Okay. One of the points he makes, and it's very important, is that he pointed out rightfully that we don't have a quantum theory of gravity, but we do have a place where quantum and gravity physics are unified. And that's the Planck scale. So that space-time becomes a quantum foam where the Planck scale, where black holes appear and disappear because of quantum uncertainty following the uncertainty relation. And next. Okay. Now, from the Planck scale, we have a fundamental mass and a fundamental length, fundamental time. And that's ultimately what we know. We also have electric charge, but those are the things that our senses and experience, you know, give us, you know, masses, lengths, times. Time is a heartbeat. Length is my arm. That's a meter. Heartbeat is about a second. And mass is a good mug of beer. So, okay, if you take the field equations of general relativity and just do a dimensional analysis on them, and dimensional analysis is incredibly powerful because I use it to always check my equations. That's why I hate for things to be done in dimensionless form, because it's very easy to make a mistake that, you know, if you're doing complicated math and you've reduced the speed of light to 1 and, you know, et cetera, you end up with equations that relate just a number to a number. And that's useful as a final result, but you have to be able to track your units and your dimensions. So if you take Einstein's field equations for general relativity and just do a dimensional analysis on it, which is what Salvatore did, you find out that the constant big G, Newton's gravitation constant over c to the 4th power, is an important, it has important dimensions, because on one side of the equation, you have on the, let's say the, one side of the equation, you have the Ricci, the Einstein tensor, and that's got units of 1 over length squared, 1 over r squared. And then you have energy density on the other side of the equation, the Maxwell stress tensor or some other kind of stress tensor. And then you have this constant, G over c to the 4th, that makes everything work out right. So if you just solve for the dimensions. What are the dimensions of g to c to the fourth? This very important constant in this very important equation that runs the universe. You know, I'm a big follower of Einstein, and like Einstein, I'm a little skeptical about quantum mechanics as it's understood. It works, but at the same time, Einstein said God doesn't play dice with the universe. In an imaginary conversation with Al, I pointed out, yes, Al, but God does own a very fine casino where dice are played. But in the meantime, you get the result when you just do a dimensional analysis that 8 pi g to the c to the fourth, you know, just that is the units of a length divided by an energy, which the inverse of that is it's 1 over a force. Now, Einstein's theory is not big on forces. If you do the geodesic equation, things don't feel forces, they move in space-time, etc., etc. But right in the middle of Einstein's equation is force, a force. And Salvatore calls this the superforce because it's supreme. And this is very important. This next. How you interpret things is how you conceptualize them. And this is supremely important. Do you look at this thing as energy per length of a string, which is how I heard it interpreted? The string theory people said, oh, this is how much energy is per unit length of these strings. And no. Well, here's string theory. It's no joke. It's got a lot of loose ends. And if you talk about string theory and energy per unit length on these strings, that's very interesting. And it's led to a lot of grant money and physics wandering in the wilderness for 40 years. But the units of energy per unit length is actually force. It's work per length. Work is energy. So suddenly, I mean, I will confess that for years I had thought this was energy per unit length of a string, that's what that constant meant. And now suddenly I realize, oh no, it's a force. It's a force, like something like a rocket. It's force, brute force, if you like. Very powerful force. And that changes everything conceptually about this. And we can, well, I'll just say, like when they first found splitting of lines of the spectra of hydrogen in it, when they put the magnetic field on the hydrogen and excited it, they got a split in the spectral lines, and they were doing matrix mechanics at the time. They did a lot of all this math, matrix. And no, somebody said, oh no, the electrons are actually acting as if they're little spinning spheres of charge, creating magnetic fields. So they're magnetic, they're spheres with magnetic fields, like the Earth spins and has a magnetic field. And that's how everyone understood it. Until they understood that, they didn't really understand it. And that's how we understand spin, not through spinors, which are, you know, a piece of math that no one can explain simply. But if you have something that's spinning, okay, I'm just a plasma physicist. I'm trying to harness fusion, by the way. We deal with quantum mechanics as little as possible, except when it comes down to the nuclear force. But, you know, if quantum mechanics puts a hole in the wall, we hang a painting over it. You know, that's what we do in plasma physics, because we're trying to solve a real practical problem here. And so this is a conceptual breakthrough, in my opinion. Right in the middle of an equation that basically did away with the idea of forces. Even Einstein said, you know, there are no forces. Everything is in free fall. Oh, no, right in the middle of the equation is a force. Next. Force, just like a rocket. Okay, so Salvatore has, and he used H star for H bar, just, you know, very rationalized Planck's constant. And he used LP as the Planck length, and he came up with this force at the gravity force at the Planck scale. It's the force between two Planck masses separated by a Planck length. And it's got big G in it. And in fact, when you cancel everything, you end up with this force G is c to the fourth divided by G. And this is a force. It's not a energy per unit length of a string. No, it's a force. Next. Now, I, of course, have this gem theory. And what I'm looking for immediately then is, you know, I'm sorry, friends, if your head is a hammer, everything looks like a nail. So you think, well, I got this theory. How does this new result conceptually fit into the theory I have worked out, which gives us some nice numbers, gives us a formula for big G, for one thing. And that uses a mesoscale, a fifth dimensional size, about the size of electron, classical radius, and it gives us a mesoscale mass, about the geometric mean of a mass of the proton and electron. And it gives us a formula relating the really the ratio of difference of energies of strength between gravity and E and M between a hydrogen, you know, for a proton and electron, that is given by, to very high precision, by the number 42.85, which it's the ratio of the mass of the proton to the mass of the electron to the 1/2 power. So you can use that formula to figure out what G is and put that into the Pais interpretation and see what you get. Next. And what you get is something quite fascinating. You get that the Pais superforce is in fact the Planck's constant. And Salvatore had kind of lamented, he said, even though this is a quantum force, it doesn't, you know, Planck's constant doesn't appear explicitly. Yes, but if you use the gem expression for the gravitation constant, which gives it to high precision, then suddenly Planck's constant pops right out. And it's the force between two charges with the what you could call the Planck charge between them, separated by a fifth dimensional size, times this exponential factor, which amplifies it. And basically it is h bar times c, which has units of electric charge, separated by the Planck length squared. So if there's anything that GEM contributes to this concept, it's that possibly he was looking for Planck's constant to appear, and it appears when you use the GEM expression for big G. So I was very pleased with that, and I really think Salvatore is onto something. I think he's found something very profound, and it's conceptually profound. The math is simple, but the conceptual breakthrough, I believe, is quite profound. He said what we thought was, and what we'd been told for the last 30 years or 40 years, had to do was pointing at string theory in general relativity. No, it's pointing to force. Forces that move things, that actually, so instead of something very abstract and impossible to explain, it seems like, instead you have that the universe runs on force. I'm sorry, it does. Force is important, even when it's brute force. Next. Now, there's other work by Salvatore, and I'm very aware of his discussion of the Schrodinger equation, Dirac equation. Since I'm not a quantum field theorist, not that I'm certainly familiar with the concepts, but I haven't worked it into my own work yet to any great degree. I refer to my work as a Bohr model of unification, because after the Bohr model of the atom as a solar system, it gave the right spectra. It conceptualized the atom as something that people could understand, anyone who looked at the night sky. So now, what I've done is I've looked at other areas of Salvatore's work, particularly his patents, one patent in particular. And so just as his discovery of force in the middle of the supposedly force-free equation of general relativity, so just as that revealed quantum, the Planck's constant in the center of that force expression through the GEM expression for a big G. Now we look at his other idea, that is that if you surround an object with two conducting shells and you put a very strong electromagnetic field in between them, like with microwaves, which you can do, that you can change its inertia. And that's one of his patents. And if you succeed with this well enough, you can fly right around corners, and nobody inside the ship actually feels any forces, because they don't have any inertia effectively. So the equation that gives this in the GEM theory is what's called the vacuum Bernoulli equation. It's Poynting flux squared, radiation pressure squared, over some kind of background energy density, like a 0-point energy. If you take the difference between that and the gravity energy density, from just classically Einstein, you get a energy density in gravity fields from Newton's field of gravity, and you can generalize this expression, by the way, to general relativity, and it becomes the expression for it's the action, the Hilbert action for the Kaluza-Klein theory, combining the action for electromagnetic fields with the action for geometry. So you have this constant. Basically, what it says is if you increase the strength of electromagnetic fields, like microwaves or something in an area, you're actually increasing local gravity, space-time curvature. So next slide. Okay, now if you apply this equation to the GEM theory, it says you can generate a lifting force with rotating three-phase powers. It's called creates a pointing vortex. This was invented by Tesla, who was trying to unify the field electromagnetism and gravity right up until his death, just like Einstein. So that says you can do this in the GEM theory. Next. But there's something else that happens. It turns out gravitational energy density is a kind of an odd thing, because viewed from a distance, it has a negative mass density. And you can see that very easily if you had a spherical shell made of, unobtainium or something, and it was so heavy that planets or little, or just even something a milligram size circled around it. And then one day it collapsed with its own gravity in a completely spherical manner. Let's say it was not spinning, and then it just collapsed on itself, and it formed a compact mass. According to general relativity and every other theory, Newtonian theory, both agree that the distant mass orbiting this spherical mass that is now collapsed, or even as it's collapsing, that orbit will not be changed at all. In other words, mass at a distance inside the orbit is not changed, even though the geometry of this object has changed dramatically. It's become much more compact. It's falling in on it's imploding due to gravity, and that generates a lot of kinetic energy, which supposedly should raise the mass of the whole object by E equals mc squared, but it doesn't, because the mass at the distance also includes negative energy density due to the increased gravity fields. As you make the thing more compact, there's more g squared, gravity energy density, divided by big G, which has units of energy density, only it's a negative energy. So the negative energy created by the gravity compensates for the kinetic energy that's being produced, so that the object orbiting out by the planet Pluto, it doesn't notice anything. The sun collapsed on itself. It doesn't care. Its gravity is completely unchanged. In other words, it sees the same mass at a distance. And that's because gravity energy density, even though it looks like an energy density in an ordinary stress tensor, it doesn't appear in general relativity, except as part of the Ricci tensor, where it's compensated for by tidal forces. So it actually has a negative energy density. And even though people say, oh, gravity fields don't have mass, yes, they do, because that's how you get gravity waves. And you get gravity waves basically, whoops, something happened here. So you get a negative mass contribution from gravity fields that are intense, especially. Next. Now, Pais pointed out in his patent, even though he didn't reference the GEM theory, I'm not offended at all. A lot of people don't know anything about it. They think GEMs are something you give your girlfriend. No, inertia reduction through intense electromagnetic fields surrounding an object. So if you have a object and you surround it with a metal shell and then another metal shell outside that, and you fill it with very high energy microwaves, according to the Pais concept, Salvatore's concept, which he patented, the mass or the inertia of the object should be reduced. And if you do this really nice, you can maybe make the mass of a 1,000-ton starship become a milligram and boost it to the speed of light in a few seconds rather than years, because it has no inertia. So if Pais is correct, if you surround a mass with a shell of high energy electromagnetic field, you'll reduce its inertia. And as it turns out, because he pointed this out, I discovered that you get the same answer from the gem theory, from the vacuum Bernoulli equation. You don't just get a lifting force. Not only does the object lift off the ground as if it has negative mass, it actually has negative inertia. So, next. And it's right there in his patent. So, I naturally believe my own theory, but as it turns out, other people are stumbling, and by the way, I stumbled on all of this. I'm just doing my job. And as a physicist, serving the country and humanity as a whole. Now, Salvatore came upon the same idea that if you surround an object with very high intensity electromagnetic fields, like in a shell, between two conducting shells around it, you can reduce its inertia. And that's in his patent. So, he stole my patent before I even thought of it. I'm so upset. Anyway, no, I'm happy. I am happy that my work is supporting his work, because he's already got the patent and I want him to be able to continue his good work. He's on the right track, in my opinion, because the gem theory works, and that means I believe his stuff is going to work. So, next. Okay, so in summary, Pais' physical interpretation of superforce appears very useful. Let's get away from, they've conceptualized everything in terms of strings now, but there are no strings attached in this universe. I look at the night sky, I don't see any strings holding everything up. I'm being facetious, of course, but no, what he found was a superforce in the middle of an equation that supposedly doesn't have any force and was interpreted as not having any force in it. They said, oh, this validates string theory because it's a energy per unit length of a string. Their whole language, like instead of saying adjoining vector spaces, they say, oh, tangent fiber bundles. I kept thinking, the universe is not made of fibers. It's spaces, and they've changed. They've even our whole language has been of how we describe physics has been, in my opinion, warped because of the dominance of string theory on physics. my joke is that if the U.S. Air Force, with our brave pilots, actually downed a UAP, let's call it, a fig leaf of a term, in my opinion. Let's say they downed a UFO and had wreckage, as was testified in Congress. Do you think they're going to call a string theorist to come look at it? No. He'll look at it and say, well, I don't see any strings. I don't understand it. Now, Pais has done something very important and something very straightforward. He just did dimensional analysis, which is very powerful. It gives you the right answers, sometimes, very exactly. So he found a superforce in an equation that's not supposed to have any forces in it. And numerous areas of agreement between Pais and, I will also say, Hal Puthoff. You can get the vacuum Bernoulli equation from Hal Puthoff's ideas. I'll be talking on that here at APEC sometime in the near future. And of course, then the gem theory also gives you this vacuum Bernoulli equation, which validates, or let's say is very, it's very supportive of the idea in Salvatore's patents of reducing inertia of objects. So just like Bryan said earlier, we have this stuff sitting right here in front of us. We just don't recognize it, but we will. Anyway, so I'm very encouraged by all of this. And Salvatore, if you're listening, keep up your good work. More power to you. More force. Force. Anyway.
Okay, well.
Part of also what we have to do is talk about the context of the situation we are having this meeting in. And that's very serious. And so if we have, we can pause for a moment for questions, but I would like also to then immediately go to my very brief further presentation, which
okay, well,
why don't we all agree is very serious.
Why don't we do that for a moment? And John, do you want to try and present that one?
Sure.
Okay.
Oh, okay. Yeah, let me try again.
Okay. Yeah, give it a try, which is called How Serious This Is.
Actually, I'm having some.
Here,
I just had to update my antivirus stuff. I visited a website talking about Russian results, and ever since then, I've been getting a lot of interesting error messages on my computer. So let's, you could just pull up this thing.
Lots of lately. In fact, I just heard somebody else mention, but I've had lots of wonderful young ladies from Singapore who want to be my friend on social media.
I'm so pleased for you.
Aren't you happy? Yeah. And
I'm very pleased for you. The girls from Singapore are
wonderful. They're wonderful.
Hey,
they're all,
the first time I
amazing.
married the girl next door, and the second time I married a girl from Singapore. And they were both lovely and gave me wonderful children.
What if they're bots?
Yes, I'm pretty sure they're fembots.
I was not married to two bots, but yes. Now, okay, let's talk about something really serious here. This is the context. This is the big picture, you guys. Sometimes I think I'm being led down a long tunnel like Alice in Wonderland. Only one chamber has zombies in it. Another one has vampires, some of whom are very hot, but that's okay. Anyway, yeah, we're having some kind of trouble. Probably because I'm talking about something serious here. And a lot of people want to know about it. Yeah. Let's see. Okay. we're having something very interesting happening. Are you guys seeing this?
So I'm sharing it. You should be able to see the screen on the, you should be able to see the PowerPoint.
Okay,
on the screen.
I can see you, but I can't see my own screen, interestingly enough. Just as I'm about to tell you guys big picture on this.
Oh, it may be maximized, John. It may be maximized.
Okay, here, let me
try moving your mouse.
Okay, here. Okay, I'm gonna just, okay.
And here, let me stop sharing, and then I will try and share it one more time.
Okay, I'm terribly, oh, okay, now, okay.
There we go.
Let me get to this very quickly before something else happens. Okay, how serious is this? Thermonuclear components apparently are identifiable in the interstellar samples gathered by Avi Loeb and his team, suggesting at the very least he may be looking at remains of a failed Project Orion type interstellar probe propelled by thermonuclear charges. Here, I'll show you this. Next. Okay, so they identified something that came in faster than anything they'd ever seen. It was also very tough. It was tougher than any nickel iron meteorite they had watched come in, because the satellites are constantly watching for tracks. We're looking for incoming ICBMs. So this one came in, and it didn't, unlike a lot of meteorites, it didn't break up until the very base of the atmosphere. It blew up, it melted and then disintegrated, only about a kilometer up. So anyway, Avi Loeb and his buddies went out to the Pacific Ocean. This was seen in 2014 by a bunch of satellites. They measured the speed, they measured how deep in the atmosphere it got. This thing was really remarkable. It came in faster than anything I'd ever seen. It came in at free fall velocity from interstellar space, and it lasted much longer than anything they'd ever seen coming in. They calculated the forces on it. This thing was really tough, tougher than any nickel iron meteorite, which is kind of the, basically nickel steel. Next, so they went out and recovered debris from it, and they confirmed it was interstellar. Now, I worked for 9.5 years at nuclear weapons labs. I didn't work on nuclear weapons directly, but I worked down the hall from the people who did. So I was briefed several times on the basics of nuclear weapon design and components. And, this stuff used to be classified. It's all unclassified. This diagram is taken from Wikipedia. Basically, it shows that a thermonuclear warhead has two parts. One is called the primary, and that's basically a plutonium bomb, a Nagasaki type bomb. And one of the important components of that to make it very lightweight is beryllium. It's also got uranium, just natural uranium. It's got plutonium in there, but it's got also natural uranium, because that's a good neutron reflector, or it's also a good inertial tamper, but it's got a lot of beryllium in it, because beryllium reflects neutrons really well. It means you can have a much more compact atomic bomb than otherwise. Now, then the secondary is the cylindrical shaped thing down there. That has a lot of lithium in it. They used to think that lithium-6 was the right thing to use, and then they tested it, just natural lithium, and in what's called Castle Bravo, and it produced 3 times more output than it was supposed to. It was supposed to be a 5 megaton shot. It was 15 megatons. You can imagine the trouble that caused. It killed a couple people because of the fallout. So a modern thermonuclear weapon has a lot of beryllium in it, a lot of natural lithium, and a lot of natural uranium. They use that as a tamper. The radiation case is made out of natural uranium also, because it confines the radiation to help everything. The radiation pressure runs the bomb. And when the fusion reaction happens, it releases such powerful neutrons that it actually fissions the uranium-238. Normally you think 235 is the thing that fissions. Oh no, when you have a fusion reaction, it releases 14 MeV neutrons, very powerful. They actually split atoms of ordinary uranium. And so roughly 70% of the yield of a modern hydrogen bomb is due to the radiation case and the tamper that are made out of just natural uranium. They also found that natural lithium was much more powerful than refined lithium, lithium-6, because it had a mixture of lithium-6 and lithium-7. So a hydrogen bomb has a lot of beryllium in it for the primary, and on the secondary, it has a lot of uranium, natural uranium, and a lot of lithium. Next. Now, things that fall out of the sky normally have this sort of pattern of isotopes or atomic weights. And from this, you can extrapolate what the rest of the universe is made of. It's all produced by stars. Of course, the most dominant element in the universe is hydrogen. Then there's a lot of helium, because helium is the first thing made by stars when they burn. That's why we can see them. That's why we call them stars. And then it makes a lot of carbon and oxygen. It also starts making aluminum and titanium, two lighter elements that are fairly common metals. It makes a lot of iron. And it also makes a lot of nickel, because those are the most stable elements that can be produced by stars. In fact, beyond iron and nickel, you can't get any more energy from fusion. The rest of this stuff is produced in supernova explosions, where the star explodes, makes a whole bunch of heavier stuff than nickel and iron, and finally out to uranium and thorium. So uranium, and what's really interesting is in the crapshoot that of a nuclear physics, beryllium and lithium are not favored to be created. So after helium, you get lithium and beryllium, and they're very seldom made in nuclear reactions in stars, even in supernova. What's made is carbon, and by the way, the third most abundant element in the cosmos is oxygen, which makes water the most important chemical compound in the universe. It's a combination of oxygen, the third most abundant element, and hydrogen. So, but lithium and beryllium are very rare, and even more rare is thorium and uranium. Next. But iron and nickel are very common. Now, they have recovered debris from this debris field. They have identified that the iron isotopes, one of the most common elements in the universe, don't match anything in the solar system. They're different than any other meteorite in the collections. That means this thing, just like its trajectory indicated, is interstellar. It's from another star system entirely. But what's also interesting is that it's full of iron, but there's hardly any nickel. Nickel is 1 part per thousand, where normally nickel iron meteorites, nickel and iron are always associated in meteorites because they're very similar chemically and they're very similar in terms of nuclear force. So what's really odd is not only is there a lot of iron in this thing, but there's hardly any nickel. And that makes this look really weird. Turns out there's a lot of titanium and there's a lot of aluminum and a lot of titanium, much above normally what is found proportionally in meteorites. So hardly any nickel, lots of titanium, lots of aluminum, some iron. This looks like aerospace alloy. They use aluminum, titanium, steel for landing gear on aircraft. It doesn't have much nickel in it either. They like the nickel doesn't really contribute much to the strength of the steel, so they leave that out. So a lot of steel alloys don't have any nickel in them. Nickel is only used for certain special properties and for making nickels. But aluminum, titanium, those are very strong and very light. They're mixed often with steel to make a very high strength alloy that's used for aircraft landing gear. And in this, so that's what this thing looks like. It looks like somebody melted down a big chunk of aluminum, titanium, steel with almost no nickel. It looks like a product of technology, not a natural object at all. Now, next, put on your tinfoil hats. This is where we get really serious. Not only does this thing look like a molten piece of what used to be a technology from interstellar space, but it's full of lithium, beryllium, uranium, and thorium, the components of thermonuclear weapons. I'm sorry to break this to you guys. You know, I was alerted to this because I'd already identified what looks like a thermonuclear holocaust on Mars, but that happened before there were dinosaurs on Earth. That happened probably 500 million years ago. Whoever did that was long gone. And that did not look natural, by the way. It looked like somebody was targeting somebody for some reason. But this happened in 2014. This thing came in 2014. So I'm going to put a fig leaf on this. Next. Based on its trajectory, which looks like a free fall trajectory from interstellar space, it looks like it was a Project Orion type nuclear charge propelled spacecraft whose braking charges, which was aimed at Earth, and whose braking charges failed to operate. So it impacted into the atmosphere rather than going into orbit around the Earth. It was intended to, this is what it looks like. It came in on free fall velocity, and it looked, you know, it would have looked like, gee, you get near Earth, you set off a bunch of nuclear charges to brake. The brakes failed, and it hit the atmosphere instead, rather than going into orbit around the Earth. So either that or whoever was programming it detected human civilization, decided that setting off a bunch of thermonuclear weapons, thermonuclear devices, let's call it devices, near the Earth would probably cause talk and not lead to friendly relations later. So they decided to just let it burn up in the atmosphere and hopefully disguise their technology. But next, we owe Avi Loeb et al. A big thank you. They have shown that it is possible that the human race, my friends, has been discovered by somebody. And they sent a Project Orion type nuclear propelled probe here to see who was playing their stereos so loud in the neighborhood. So we don't have to impute anything hostile to this, but there's a Hindu proverb from India. It says, the thread will always follow the needle. So friends, we face a serious situation. And the time we have to push in this forum, APEC, to try and get the human race enabled to go interstellar, to develop gravity modification for flight, and finally for warp drive between stars. It might be advisable also for us to start our own Orion type program. Now that we have easy access to space, we could test such a thing far away from the Earth so there wouldn't be any fallout. The solar wind would blow all the debris out, especially because we can make very clean hydrogen bombs now, neutron bombs. So, but I wanted to tell you, now this has been accepted for publication at a journal. So it's coming out soon. I'll inform you when it comes out. So my friends, I believe we face a very serious situation. People ask me what the living universe that we're going to be joining is like. And I say, well, our initial reaction is just like when Luke Skywalker and Obi-Wan Kenobi walked into the Mos Eisley Cantina, the bar. It was a dive bar in Mos Eisley. And Obi-Wan Kenobi, kind of the father God symbol in the movie, says, the best space pilots are to be found here, so we have to go in here. But watch your step. This place can get a bit rough. So you guys are going to have to be tough. I went through 9/11 in Washington, D.C. I was part of the defense and intelligence community when we went through that. We'd been expecting something, and it flew in right under the radar and got us anyway. And I remember standing there watching the towers fall, collapse on a big screen TV in the conference room. Everyone was standing in there watching, horrified. And the guy next to me burst into tears when the first tower fell. His name was Frank. And I patted him on the shoulder and I said, Frank, you got to get a grip. This is like Pearl Harbor. We're at war now. This is serious. You gotta chill. You gotta get a hold of yourself. I mean, I was barely holding on to my own emotional equilibrium at that point. I had chilled. So some other associates took him out of the room because he couldn't get it back together. And we all watched horrified as 9/11 unfolded. Finally, the Pentagon itself was hit. So, friends, I think we face, I just mentioned that because I've seen what happens when your worst nightmares happen. And the idea is to prevent them from happening. And so I wanted to just inform you guys that that is, as someone who worked at nuclear weapons labs for 9.5 years and got pretty well briefed on how they worked and everything, that's what the analysis that Avi Loeb and his associates have published shows. It shows what apparently was a melted remains of a technological alloy hulled spacecraft, and it was carrying nuclear devices, thermonuclear devices. That's how I'm connecting the dots at this point. So this is very serious, you guys.
Well,
This
John,
relates to our global security. Thank you, and that's all I'm going to say.
Thank you. Thank you, John. Thank you for presenting that. Let me go to gallery view. Everybody, we need to give John, Mr. John Brandenburg, Dr. John Brandenburg, an enormous applause for talking about the Pais Superforce as well as Avi Loeb's interstellar samples. John, that is wonderful. Let me open this up for questions. Let me see.
Just
Honey
doing my
Radiance.
job.
Honey Radiance has a question. Let me go to you, sir. And can I get your first name if it's okay?
Oh yeah, Rick.
Rick. Okay, let me
Rick.
rename you Rick.
Rick,
Yeah.
how was the barbecue?
Oh, it was great.
Oh, good.
Good.
I was thinking about that, you know.
I was thinking about that too. I was like, you know what? I want some. But
Yeah. I had to go away for a while, so.
Yeah, I understand. I thought you had urgent business that you had to attend to. Yes.
So yeah, I watched your videos in the past about Mars and the possibility of extraterrestrials being hostile.
We're right in the front door of Mos Eisley Cantina in Mos Eisley Spaceport. I'm sorry.
So, but I have questions or issues, or I
Yep.
don't know, maybe slight disagreement.
Sure.
It seems that at least going by Earth, by human civilization, that the center of evil in government at government levels starts from Malthusian scarcity, control, depopulation, closed system thinking, as opposed to like win-win cooperation, like Lincoln Kennedy. So a civilization cannot achieve a high level to be able to travel interstellarly unless they somehow gotten control of their deep state and corralled or quarantined their evil and became
One
good.
hopes. One
Or
always hopes.
Unless they've become evil and they're coasting on their former technological achievement, like the United States is right now, as a pawn of the British Empire, using its technological prowess to fight wars and stuff, but was once good and developed the technology when it was better.
Just like
right?
Rome.
Right, like Rome is a good example. So it would have to be a falling or a decadent alien civilization.
yeah, I would, yeah. And
Well,
Rick,
it could be completely innocent. It could be just an interstellar probe, using a Project Orion type propulsion system of nuclear charges.
I mean, the one that
could
destroyed
be completely innocent.
I mean, the one that destroyed Mars.
Oh, the one that destroyed Mars. Oh no, that does not look like it was innocent at all. It does not look like it was natural. It looks like it was targeted.
Right.
Attack. That's how I connect the dots. And I just told you I went through 9/11 in Washington D.C.
Yeah, if I could jump in, I know, I went through 9/11 in the Seattle area. I was at AT&T. I was in Redmond actually, and I have some vivid memories from that. I think all of us do. We just went
I
through
had
the
nightmares
anniversary.
about it for years.
Well, no, okay, so that is something else. Johnny, if I could just interject for a moment. A friend on LinkedIn messaged me and said that they said this time of year they always see the falling man, and the man falling out of the building, right? And there were many, but there was one in particular. They described him, and I was like, yeah, I remember that. And so one of the things I think all of us need to be cognizant of, if I could briefly share kind of my story. So I was at AT&T Wireless, and for me, I saw the first plane hit the tower. My wife had gotten up and gone to work like an hour and a half early. She had an early shift. I was sleeping in because I'd been at work super late the night before. So I missed the first plane. She called me and said, "Hey, a plane flew into the World Trade Center. You're not going to believe this. It's a horrible accident." Right. So I woke up and turned on the news just in time to see the second plane hit. And then like everyone else, everyone in the United States, everyone in the world, it was like, oh, guess what? Not an accident. And so when I went to work, I actually tried to work for a couple hours. I think most of us did. We went through the motions. And we ended up just gathered around TV sets. They had these TV carts. They were tube TVs at the time, either end of this enormous AT&T facility. And we all just basically stayed there and just watched repeats of it over and over and over and over, and just talked quietly, and nobody knew what to do. Everyone was in shock. And eventually we just kind of went home. Right. And pretty much everyone in the United States, probably many people in the world, because they had their TVs on, did the same thing over and over and over. So you have a horrifying event, emotionally traumatic, and it's repeated over and over and over. And so I think all of us have some level of PTSD from that, you know.
Oh, I did. I diagnosed myself as having it, you know, and I actually found myself thinking, oh, that was a movie. It wasn't actually, it didn't really actually happen. And,
I
then
mean,
I had to shake myself and say, no, John, it actually happened.
Now, the other part of that is I have friends who were in intelligence, and people that you know. I have friends who were in the intelligence community who went through September 11th, and this is just my personal bent. I'm sure that people will hate me for saying it, but there's been a conspiracy theory about a plane flying, or about a bomb or a missile flying into the Pentagon, and
I think that's a whole nother APEC session. I can actually looked at the Pentagon from a lookout point.
So
a few days
the
after
story
it happened, and I was driving to work, and I pulled off what I thought was just a shoulder pull off at the highway overlooking the Pentagon. I could see everything, including all the light poles that had been knocked down in the parking lot
from the plane.
And I stood there kind of absorbing it all. And then suddenly 4 police cars pulled up next to me and said, "What the hell are you doing here?" And I said, I and they said, "Don't you know this place is forbidden?" And I said, "There's no signs." And they said, get back in your car and get moving. But I saw all of the parking lot.
So
light poles have been knocked down by something with a big wingspan. So I'm just telling you what I saw.
No,
I don't know what happened. We don't even know exactly what happened at Pearl Harbor.
It was definitely a plane. And the thing is, the problem with it was, and I kind of learned this a few years later, what had happened, as I'm sure you know, because you were in that area, but what had happened was so horrifying that the government basically, and people didn't want to talk about it. And
no, they didn't.
The DOD asked them not to, because it would not be good.
So there was an information embargo immediately.
Yes. And, and I had asked someone that I was close to, who was there and, knew all of the details, all more than the average person on the street, what had happened. And he said to me, "You don't want to know." And of course I was, I was much younger, and I said, "Oh, I want to know." And then
you want to know, but
he told me. And
don't.
then when he was done, I realized, you know what? He's right. I didn't want to know.
Yeah, I only mention that to say that coming from my background and experience, we should, if you start connecting dots and you see something potentially dangerous, if you see something, you should say something. And there were a lot of signs. It's just like after Pearl Harbor, there were a lot of signs that could have warned people. There were people who actually had it right on the table in front of them a few days before it happened at Pearl Harbor. And they were at Pearl Harbor. And they said, "Nah, that can't happen. That would be crazy."
Thank you.
So I'm just telling you guys, this is a very serious situation. The probe that Avi Loeb apparently found debris of was definitely interstellar, based on the isotopes, based on its trajectory. And it was obviously made out of some very tough alloy, looking like aluminum, titanium, steel, no nickel. It wasn't a nickel iron meteorite. Nickel iron meteorites are like 20% nickel. And normally you never find iron in a meteorite, with a natural meteorite, without finding, like 10% nickel there with it. So, and then it's got beryllium, lithium, uranium, and thorium in it. but by the way, it's got a lot of rare earths. I don't know what that means. I have no idea.
Question.
Yes.
So do you think it went slower than light? Light in a rocket?
Oh yeah. This was not a. This thing fell from interstellar space. It looks as though it was a long-range probe traveling sublight. I mean, this is just what it looks like.
Mm-hmm.
And it looks like it came to the edge of the solar system and basically slowed down to match the velocity of the sun, and then fell in at basically just free fall velocity in towards the Earth's. You pick up about 42 kilometers a second, just falling in under the sun's gravity. And then you get to the Earth's orbit, and depending on what angle you're approaching, the Earth's got an orbital rotation around the sun of 30 kilometers. So you have to vector sum everything. And this thing came in at roughly about 50 kilometers a second. So it was it was even in excess of the free fall velocity. There may have been some component where the Earth kind of flew into it a little bit. But instead of slowing down and like going into orbit around the Earth, like a probe you would expect, it just impacted in the atmosphere. For all I know, it could have had sensors on it. They measured enough soap commercials and political propaganda from the Earth that they decided to lose interest in us. And, I'm just saying, that it apparently had nuclear device charges on board to break, slow down, and go into orbit around the Earth. But it decided either they failed or the computer on board decided not to fire them to avoid alarming. Not only would those be easy to detect if they went off near the Earth, the humans are easy to detect as you approach the Earth from our radio broadcasts, but they would also realize we're probably easily alarmed given our history, and that it would not make a good basis for future relations if they set off a bunch of nukes near the Earth to slow down this thing. So they just let it impact in the atmosphere. That's one way.
Sounds like they know themselves.
That's a very basic interpretation of that's how you can connect the dots. There's nothing threatening particularly about that in that scenario. And it explains what is seen. The only problem with it means is that we may have been discovered by someone. And given our own history, that cannot, sometimes there's a downside to getting discovered by people. Maybe
John,
we'll be made star in their latest movie. Who knows? We'll be discovered like in Hollywood. But
I should probably just remind everybody, and you guys definitely, the folks who are in this call right now, you guys need no reminding. But so NASA said this week they basically talked about their estimate that they believe. Sorry, I'm going to put this thing on Do Not Disturb for a sec. There was an estimate that there may be trillions of habitable worlds in the universe.
Yes.
I mean, so the numbers that I have, I've been doing Drake equation stuff for the last couple of months. That came out of UAP stuff. So my feeling, and again, if I could ramble just for a moment, I know I'm moderating, so I usually don't, but I spent probably about a year doing UAP interviews, and everything that I've seen substantiates, this idea that, okay, something is visiting us. And from a space science perspective, that shouldn't be any surprise. This is what Arthur C. Clarke and, all of the greats were telling us for decades, right? They were saying sooner or later, somebody's going to show up. They may have been here for a very long time, so sooner or later we'll figure it out.
Oh, there's a multitude of agendas out there, and most of them are. I mean, obviously, we're having this conversation. Most of those agendas must be.
So there are
100 years of broadcasting.
There are about 400.
Oh, absolutely. I'm waiting for somebody to show up and tell us to turn down our stereos.
They're about there are between 100 and 400 billion
AM.
stars in the Milky Way galaxy. And you know, it is estimated, I believe Drake himself estimated around 10,000 of those probably have advanced intelligent civilizations, as advanced as us or more
Yes.
advanced, right? One of the things that he didn't take into account, there were two things that he didn't take into account. One of them would be that civilizations rise and fall. He knew that. He didn't assume that they would rise again. So a planet like Earth, we've seen this several times. Rome comes and goes. The United States comes and someday will go. He didn't take that into account, which probably means there are more than 10,000. The other thing he didn't take into account was colonization, right? Like us exploring and eventually colonizing Mars, the asteroids, someday Alpha Centauri, all of those things. So the number of civilizations out there that are flying around are probably over 10,000. And for me,
Yep.
the truly profound thing is that for each one of those, there may be thousands, maybe millions of planets with primitive life. So when we look,
Yep.
you know, when you look up at the stars at night, this is something I try and remember to myself is we, in many ways, we are not children anymore. Our species is on the, we're teens, right? As a species, we're like teens.
Oh, yes. I think we've done very well for ourselves.
Yeah. And from that perspective, when next time you look up and look at the stars, I mean, statistically
Be sure and wave.
It is
People will be waving back.
it is very likely
Yeah.
that tens of thousands of advanced species and potentially millions, tens of millions of planets with life of some kind, right? I think that's wonderful. I think that's wonderful. So
I wanted to that brings up an interesting point, Tim, is if the people at Jeremy's lab were to build an interstellar starship, right, and we were to go to a nearby exoplanet, somebody else probably intelligent would have colonized it, may have colonized it already. And so if we were to go to like Epsilon Eridani or something like that, his chances are that the intelligent life there is not native to that planet, but is from somewhere else, right?
it's entirely possible. Yeah.
So
yeah, I think these are the big exciting questions, right? I mean,
hey, let's look on this, that we're part of a science fiction adventure movie.
Yeah.
And that the future is going to look like Star Trek. I think that's just an excellent vision for the future.
If I could open just ask a question here, we're segueing into the how-to. I think I'd like to focus on how we can actually get some hardware into operation in space.
I think that's a very good question.
I know there's a number of people in this community who are, they're working on projects of their own. There's looking to commercialize. They've got things that work. And so my big question is, how do we, or do we come together as a community, pool in some way together? How can we collaborate, or are we all just sort of cross-pollinating a little bit?
Well,
and then
you got to test it on Earth first.
I mean, collaborating right now.
Yeah, and I would say test it on Earth first. Now, I believe Drew Arigama from sunny Florida, who is here now, I believe they're looking at testing stuff in space. And I shouldn't forget Tony Robertson about his patent. In fact, maybe we could get Tony on real quick. John, you think that'd be okay if I brought Tony?
That'd be great. Oh, that'd be great. Let's hear from Tony.
I wanted to add too. I've got something it looks like it works. That I've discovered a way to create.
Necessity is the mother of invention.
So, getting what I have in my garage orbit is kind of an orbital endeavor.
Well, you would want to test it and proof it and get larger results. You'd want to do a lot more garage work before the multi-million-dollar space launch, right?
Yeah, I need other people to do it as well, to replicate it.
Yeah.
So,
yeah, and put that out there.
A lot of great rock music was made in garages.
Yeah, exactly. We're like,
so you're open sourcing it.
Yeah, I kind of am open sourcing it.
HP and Apple
Carefully.
were starting in the garage.
That's right.
I got to tell you, screwing around in your garage is all well and good, but if you're not careful, you'll burn up 19 years doing it.
True.
The trick is get some funding,
your
get out
garage.
there, and work on it full time. Because I don't see ever not being
There's
able
Tony.
to.
Yeah, there's Tony. Well, Drew, but
There's
can we
Tony.
do this before we come to Drew? Could we get Tony to Tony? Do you want to tell us a little bit about your patent? Do you want me to put that up for people again, or do you want to share it?
Yeah, you can share it with everybody. It's been online for months now. I posted it on LinkedIn as a publication. The patent letter I got just came out like a couple of days ago, so I've got to send the issuance fee, and then after I do that, about 3 months, the patent should come out. But the interesting thing about it, the patent won't change from this application because it was a first allowance. They made no comments to anything on it, which is kind of the first for me, especially since I write them myself. But I don't want to talk too much because I don't want to jinx it yet because the patent hasn't been really issued yet.
Okay.
Tony, it looks similar
no
to
comments. There were no comments, no questions.
It's called a first action allowance. No comments. Period. Nothing.
Wow.
Not against the claims.
Called a
Not against
foundational
anything.
patent.
I never got that.
Congratulations, Tony.
Yeah.
And if you read the abstract, the last sentence, it says this device inside of it is not affected by inertia at all. I figured that would throw the patent right out the window. But
there we go. I'm able to rotate. I'm going to
like what I
rotate this
showed
for you
you.
guys.
We can do this thing. We can do it.
Yeah. But
Okay.
like I said, I
Can
don't
you
want
go
to
back to that last figure?
Which one, Drew?
Whatever, the whole thing that was on there 2 figures ago.
The two. This one. This one.
That one.
Capacitors.
All right. So what do we got here? We have an asymmetrical capacitor. Congratulations.
Go to the second.
You have effectively reinvented ours. Awesome.
Yep. Well, that's also very similar to the pause patent.
Yeah. Yeah, there's no question about it. Asymmetrical electrostatic pressure is the answer to the mischief out there.
Tony, were you talking about this one, figure 1?
Yeah, that's a simple one, other than that other one with the 4 a minute. Basically, this is a skin you would put around a craft.
The circular one shows how you could create stability.
Yeah, but
What's
like I said,
12C? What are your materials?
Well, like I said,
let me go down further.
I don't want to get too involved in talking about this to jinx it. You're welcome to get the patent and look
Is
at
it
it.
issued or not?
I got the notice that it will be issued. I've got to send them the fee, and then probably about 3 months it'll be issued as a patent.
Oh yeah, then it's issued. Yeah, you just got to pay for it, and then they'll issue it.
Yes, So
unless
I'm at
somebody
that
can
point.
test it.
But it's been online. I posted this application on LinkedIn months ago. It's on ResearchGate. Tim's welcome to post it and let everybody see it. I don't care. But like I said, since it's the first allowance, there's not going to be any changes in it. It's whatever gets the patent will be this.
Let me drop it into chat then. I will drop this into meeting chat.
What do you want to do with that? Do you want to license it or develop it yourself, or what? Like what's
there?
Your...
We go.
Well, I've been trying to build some prototypes, but like I said, I don't want to get too involved in discussing it because I don't want to jinx it. But ultimately, I'd like to get some partners together and build something to demonstrate that it will fly.
Well, this is wonderful, Tony. This is wonderful. And you know what? Let me see. Where are we at here for pages? Let me finish scrolling through this thing. And I think that we should give Tony a hand also for there we go. That's so 15 page. That's
I'm giving you
first
a
revision.
huzzah.
Yeah, here, let me, you know what? Put this on gallery, everybody. Big applause for Tony Glenn Robertson for his patent. Yeah, you guys, thank you everybody for being here. I see Jim Woodward hiding out.
Congratulations.
He's quietly hiding. Oh, okay. He doesn't want to be.
He's got
pointed
somebody
out.
else. Who is that handling things for Jim Woodward?
That's Chris Horn.
Yeah, Chris. So Chris Horn is here, but I see Jim as well hiding. So
Curtis,
There's Jim.
There's Jim.
Because that's the optimal frequency for the effect to work.
All right.
A few gigahertz.
A few gigahertz. Can I tear apart a microwave oven and get the tube to put that out, you think?
And Jim, how are you feeling these days?
I'm doing okay.
Good.
Yeah.
Good.
Yeah, no, Curtis, that's the reason why UATs display microwave signature. It's a propulsion system. It's a propulsion system.
I never showed you what I could do with a microwave oven, Jim.
We're perfectly happy using old guitar amps.
Hey, from garage bands. From garage bands, you know.
Yeah, I wanted to play guitar when I was a kid. I
When
was really
growing
bad
up,
at it though.
there were garage bands around my neighborhood playing at night.
My grandson's doing it in his basement right now.
Oh, in a band?
Yeah, he's trying to start a band. He was trying to decide where he would go to college or go into music. So he flipped a coin and the music won out.
Tony, you got to give him always have a backup speech.
And the kid's brilliant. He's really smart. It's his choice.
Tony.
Yes.
Talk to him.
Yeah, I mean,
talk to this kid.
If the music thing doesn't work out, get him an MBA, right? Can't go wrong with MBA.
Telling him that he needs to go to college as a backup plan, but
I agree.
He's just too smart for his own riches. So
well, just get some 2-year paper at least. 2-year college degree.
Well, we're trying to push him that way. He said that he'd go to college as long as it was in music. So whatever.
There you go.
Great. Well, anyway.
That's a wedge though. That's a wedge. You can drive that wedge in further. Music becomes math, becomes physics. See, that's the path.
I
started all done on harmonics.
I started as a music major, and I played trombone, and I had to practice 6 hours a day just to keep up. It was too much work, so that's when I switched to physics. So
I'll tell my grandson that. I think that's a good story.
There you go.
I played banjo. That's when I became a fan of string theory.
Yeah. There you go.
So John,
I play guitar.
I had something to tell you about the whole thing about meteorites.
Yeah.
I know something about it because in the last year, like I had mentioned, I was working on using non-imaging optics applications in space. And one of the applications I'm working on, the main one, is melting asteroids so that we can extract the valuables. Okay, so
sure.
I had to do a lot of research and understand these metal-rich asteroids. Can I share my screen again?
Sure.
Okay,
Tim.
Okay, so if you look at the
nice.
Wikipedia this is the classification of the asteroids. One thing that you'll notice, and then not many people talk about this, you see this line right here? It says ungrouped meteorites. So most meteorites, like you said, that are grouped have quite a bit of nickel.
Yep.
But they have about 15% of the total collection of meteorites that are metallic don't fit into any of those classifications. So you can
some
take
of them
that
very
either
nickel
way.
poor.
You'd have to go look. There's a place where
everything I
and,
looked at, was like, from 20 to 5% nickel.
Right. All of these that are grouped are like that.
Yeah,
But
the
I
ones,
would
okay,
suggest checking the ungrouped and
ungrouped.
probably talk to somebody, a geologist that specializes in this. And there's a lot of people at UCLA that do that.
Uh-huh.
And I'd be curious if, I mean, 15% is quite a lot. So I'd
Yeah,
be
but
curious if
what's
there
the
were
what's the
some,
nickel content on them? I'd be
yeah, I don't know. Each
nickel and
one
iron,
was,
nickel and iron like each other, and they form together. Let's see.
right.
Okay, it says okay, ataxites. Okay, that's
Ungrouped,
okay.
completely ungrouped.
16% nickel. A lot. If you look down the nickel,
Yeah,
they're
well,
mostly
that's grouped.
iron, and then
Right.
they've all got a lot of nickel in them.
Right. Yeah, the ataxites, that's group 4B. But the
That's
ungrouped
most of the
is
nickel
not
deposits on this planet are from big impacted iron, nickel iron meteorites.
right.
New Guinea and
Right.
and up there in Canada at Sudbury, that's a big impact.
Right. Yeah. So like I said, that's one of the groups, right? The 4B group. But the
Right.
ungrouped meteorites, I don't, each one, I looked at a few of them, they had different compositions. I mean, to me, it was a numbers game. Like the vast majority, okay, it has this much nickel. And the thing was interested in, I am interested in, is the platinum group metals, of course, and
Of course.
and and the
Hey, nickel
and the rare
might be
earths.
turn out to be. It might be someday in the future people will melt down their old nickels.
Yeah,
because it'll become really valuable.
So I would say that, yeah, we probably need to talk to a geologist that knows this whole 15% of the collection that's ungrouped, and how much nickel do they have? Are there any samples that are like this?
Well, they're actually titanium aluminum mostly, and some of them have nuts and bolts made of steel, chrome steel in them, and they can't explain that, so they just don't mention it. That's what happens.
Yeah, it could be.
I actually believe that probably some of these meteorite hunters have found the wreckage of UFOs before the government got there. And did they publish? No. In fact, they claimed discovery of the meteorite, but they called it ungrouped. And so they didn't have to give any composition on it.
Can I say something?
Sure.
It's about braking.
Yeah.
I was watching this thing on APEC before about the project's what is it called? Breakthrough Star Shot, where they use a ground-based laser to accelerate an object to 5% or 10% speed of light, shooting at Alpha Centauri. But an object remains at rest or a constant motion unless acted upon by an outside force. So
sure,
you wouldn't be able to brake on the other side because there'd be nothing to stop. No late ground-based.
Like if we were to make an Orion type probe, we'd set off a bunch of nuclear devices, nukes, let's just call them nuclear devices, and they boost the thing up to really high speed. And we probably do a gravity assist off at Jupiter just because it's nice and convenient. And then it gets to Alpha. Okay, so in fact, we have to wind around Jupiter to go south towards Alpha Centauri. Okay, out of the plane of the solar system. So we get close to Alpha Centauri. Let's say we want to stop at Proxima, check out the place. And okay, we get close to Proxima. We're going some fraction of the speed of light. So we have to brake. We have to put on the brake. So we set off a bunch of nuclear charges to slow down. And then we kind of get into, there's no point in trying to slow down until you get into the rest frame of the star you wanted to go to orbit around or investigate. There's no point in trying to slow down any more than that, because then you're just going to, you're going to fall into the star's gravity field anyway. So you basically slow down till you're basically at rest in interstellar space, and then the star pulls you in. Okay, you pick up another 30 kilometers a second, falling in towards the star. You find some planet you're interested in, somebody where the music's, they got garage bands playing, and they're broadcasting their music. So then you get close to them and you start braking again to go into orbit around that planet. So there are basically two phases. There's a braking to get into the rest frame of the star. You want to investigate this star system, you want to investigate, and then you do a free fall. It's a very small velocity, but you want to get into kind of the rest frame of the solar system and then do fine adjustments. And the fine adjustments, using nuclear charges, are when you get close to something, you want to go into orbit around some planet. And hopefully they either don't notice or they're not easily alarmed and they're expecting it. And hopefully they don't have a giant laser to try and accelerate an interstellar probe at you.
Well, yeah, that's what I mean. It's like how does breakthrough star shot, because it's supposed to be really, really light, so it can't have a lot of fuel on board. So it's just all powered by ground base. But how would you slow it down? How would you get any data when you're flying past Alpha Centauri at 10?
Guys, y'all drive me crazy with this stuff.
I know, it's crazy.
They're not going to use any mass propulsion system. Okay, I don't care if they're little green men or it's all fiction. Tim, I gotta go to bed. So can I just tell what I was going to tell? And
yeah, sorry about that, Drew. Drew, go for it.
Go for it, guys. Too. I haven't had any dinner.
Okay.
Okay. Yeah, well, Drew, give us some updates, sir.
Well, I've been spending the last couple of weeks just testing and retesting my propulsion system, which, for lack of a better term, is the Star Trek impulse engine. And I'm going to try and share a screen, which usually fails miserably. Can y'all
looks
see
great.
what looks? Yeah. Okay.
Okay. So I see a web browser. Yeah. Space travel calculator.
The space travel calculator. Okay. I just went out online and found this 9planets.org, and it's got all kinds of crap in it. But one of the things they have is this little cute space travel calculator, and you can play in Newton's universe because I don't go fast enough to worry about relativistic speeds. So what I did was just put in there what is in my vacuum chamber right now. I have a 0.1 G. Actually, it's 0.3 Gs, but by the time you factor in the mass of the spacecraft that isn't producing thrust and the astronauts' toilets and their foodstuffs and everything else, basically 100-ton spacecraft, which I don't know. Anyhow, 100-ton spacecraft. I can't show you the model because my partners will kill me. But it's a spacecraft. It's just a cylinder with the propulsion system wrapped around the outside because it has a high hydrogen content, and that's acts as shielding. Anyhow, 100-ton spacecraft going roughly 90 million kilometers, which is the trip to Mars. And this is the pretty average. This is like 6 out of every 22 months. The distance to Mars is around 90 million kilometers ish. And I'll show you what the next number is too, because it's an active thing. Anyhow, at 0.1 Gs, which is very doable with the current technology I have in my chamber, and I've proved I can scale it up. I've proved it's robust and it's continuous and whatever. It just could get the job done. It's 7 days to Mars, guys. It's 8.5 years to Alpha Centauri. Ain't nobody going out through interstellar space with no explosive rocket, boom, bang, nuclear blast coming out their butts. They're going to use something if I can figure it out, they can. Okay, because they're way smarter than I am. So if y'all want to build a spaceship, let me know, because I got the engine for it. We're talking...
Drew, where in... I believe I came and visited your lab one time.
It's possible. I'm in Oak Hill, Florida.
Yeah, let's see. Where's Oak Hill? Is that near
30 miles
Orlando?
north of the Kennedy Space Center.
Oh, okay. Yeah, I came and visited your lab. I was sent there by a guy in at DARPA, and he wanted me to go visit people doing the kind of work you were doing and see how you're doing. I was very impressed. I wrote him a nice, review of your work.
Okay. I've had a lot of people over the years.
I remember your thing is you charged up something and you got this kind of basic
How
vacuum
long ago was
polarization.
this?
What?
How long ago do you think this was?
Oh, this was like, it was like 2005, something like that.
No, you didn't come visit me. No, you
Oh,
probably
okay.
visited my previous partner, that idiot I used to work with.
Well, never mind then.
Yeah, never mind. So you are John again. Dr. Charlie Bueller sends his regards. You are always welcome in our shop. You'll have to sign an NDA, but you are
Of course,
welcome to
of
come and
course.
put your hands on a warp drive prototype. It's up
Excellent.
and
I
running.
don't know. Is it charged to high
Working
voltage?
right this second, by the way, about 12 feet to the left of me over there, behind that firewall.
Very good.
So the short and long of it is, guys, we can build spaceships tomorrow. If you know anybody that wants to fund the building of a Mars craft that can get there in 7 days, and this is, by the way, this is from low Earth orbit, to accelerate to Mars and decelerate, accelerates halfway there, decelerates halfway there, so that when you get to where you're going, you are at the orbital velocity of wherever it is you want to be.
Right.
Mars or whatever. We're talking 7, maybe an extra day, because they still gotta accelerate all that mass up. So that might take an extra day or 2 or whatever. We're just talking 7, 8 days to Mars. How much faster you want to go? This is like 14 days to Titan, which is my personal preference. I want to go to Titan and kind of walk around and check it out. But
Enchiladas.
You're talking
Go for a
talking about
swim
having
in the
flush
methane
toilets the
ocean.
whole way.
What?
Y'all are talking about warp bubbles and light bubbles and other nonsense. Let's get out there and build this thing.
I know.
If you know any billionaires that have a spare couple of pennies that they want to throw at building an actual spacecraft, send them my way. Because I'm ready to go play spaceship.
I tell people to bend space-time. That means gravity, anti-gravity, gravity modification. And that's bending space-time. But to twist it into a pretzel, that gives you warp drive. And that's a lot harder to do, obviously. But
yeah, this is the Star Trek impulse engine. This is Mars in 7 days. If that
7
doesn't float your
days.
boat, y'all are in the wrong universe, because this is
You
all
could
we're going to get
remake
to in
the
our
entire
lifetime.
the heavens and the earth in 7 days. That's
Sure.
talked about.
You're talking Venus in 4.
There you
floating
go.
City. Everyone's talking about putting balloons on Venus. 400,000 feet, 200,000 feet is actually at 1 atmospheric pressure. Okay. Well,
Yeah.
I can float a city above Venus at around probably a little higher than 400,000 feet, but still, I can see this floating spacecraft at 6,000 miles, because Venus got about the same gravity Earth does. So anyhow, there's the technology's here. I got it. I'm pointing to the screen because that's my screen over there. But
you can't tell people that Earth is a rare planet if there are basically 2 of them in this one solar system. Earth and Venus, they're basically the same size.
Yeah. Okay. The other thing is, I got very intrigued when they were talking about that Planet X out there. They did some math, and whoever they found, they kind of think there's another Planet X out there. And I keep thinking about the early solar system, when they say there were some big, whatever they were, sub Neptune classes, and a whole bunch of little rocky ones, and the big Neptune ones threw the little rocky ones out. And there's if you do the math, then the big ones get destroyed, and all that's left are the little rocky ones, and one that gets ejected. I just thought that was curious. I think we're looking for an ejected planet.
We can't see anything else out there. If there was a planet Neptune out there, we would be able to see it. So yeah, the Planet X thing is one of these. It's like who killed Jimmy Hoffa? It kind of pops up periodically, or the Kennedy it's the Kennedy assassination.
Planet
astronomy.
X, Planet Nibiru.
I could get a probe
you know
out
what?
there in 18 days. Let's go find it.
I
I
think
literally get a probe out to Pluto in 18 days.
Okay, guys, I'm going to have to let you go. I haven't had any dinner.
John, thank you again. Thank you
Thank
so
you,
much.
Tim,
We've
for
already clapped
hosting this
profusely. Let me
wonderful-
just at this point, let me thank you again. It is wonderful having you speak. It's truly an honor, sir. Thank you so much.
Thank you so much.
Thank you, John.
Yeah.
Okay. Well, and Drew, thank you for the update as well. Everybody.
Yes, Drew. More
Yeah,
power
guys,
to you.
These open mics, we're tearing it up. We're tearing it up.
Tim,
So,
this is
Thanks,
all your
John.
creation.
Thanks, John.
What-
I have to read your paper. It's very interesting.
My what's these?
Your paper is very interesting.
Oh, thank you. Thank you. Yes.
Yeah.
And well, I mean, if it gets any more interesting, it'll be terrifying, you know. So, but so far it looks like it was just I mean, if you connect the dots, it looks like the Avi Loeb results can be explained as just a interstellar probe whose brakes failed near Earth, and you know, so it's you know, I think the danger of nuclear weapons on Earth held by humans is far more dangerous to our existence than anything else out there right now.
Yeah, that's why we need to we need to civilize other planet, you know.
That's right. We need to civilize our own planet. You know? Anyway, guys, I'm going to have to let you go. And but thank you so much for your response. And please think about what you saw and do your own investigation. And thank you so much. I'm going to have
thanks
to
again, John.
take my leave now. So, bye-bye.
Bye.
Okay.
Tim,
Well, let me see. Curtis had his hand up. Maybe we could do Curtis, and then Phil, you said you had an update on your work as well. But let's go to Curtis real quick because he's just... Curtis, what can I do for you, sir?
Yeah. So earlier you brought up that NASA report, and the thing that's been on my mind is, I believe it's about at a 1.2 G. It would be very hard to get out of a planet's gravity well with chemical rockets. And I wonder, has NASA? Do you guys know if NASA's looked into? You know, we found a lot of exoplanets, so we have some data. You know, what percentage of them have that, you know, are above that limit? And the reason I'm thinking about this is that, you know, with all the UFO talk, if there is a civilization and you're in a planet where G, you know, you're at 1.5 G, whatever it is, you're not going to develop space flight until you solve the problem we're talking about solving.
That's a good point. That's a good point.
You know, that's something to think about. And you know, you have to just take the time. You can't brute forces like we have. So
I don't think so I saw a story this week about and Kepler has found a few of these, but James Webb Telescope just found a new planet with what they believe are constituent components of an atmosphere, habitable atmosphere. And so you know, they are racking up this collection of potential biospheres, right? And my guess would be that we're still in the really early stages, but hopefully they'll come back once they have a better pool of candidates and start to investigate those more closely.
Yeah, I think that just even having the rocky bodies, like what size, you know, rocky planets form, like just having that statistic is probably enough, because the atmosphere they would develop is just all, it's probably going to end up being random processes, right? Were there enough, you know, are they close enough to their star? You know, are they rotating the right way? That kind of thing. But in terms of size of planets, I think we're on the smaller end, if I remember you know, looking at it. And if that's the case, then, you know, the fact that we got to space is probably an exception, you know, with chemical rockets rather than the rule. So, yeah, that's, you know, thinking about those, you know, what John said, that we got to think about what's in that cantina. What kind of beings can be there, what technologies they have. And it's, if I remember my, the exoplanets right, what the statistics are, it's more than likely that they would be in a planet where you can't get out of the gravity well without doing something more sophisticated than what we do.
Yeah, and then the other thing that I would say, I'm going to get punched for saying this sooner or later, is von Neumann probes, right? I don't even preface it anymore. I'm just like, von Neumann probes. That's the answer to everything. But that's just because statistically, I think that we're so likely to encounter those first. And so I tend to think that a fair number of these UAP are probably von Neumann probes. But again, that's just my bent. So. But let me go to Phil, if that's okay. And Phil, you were going to give us an update on your theory, right?
Yeah, well, actually, it's been a month already. I can't believe that. Time passes so fast since my last experiment. But my last, just a reminder, a month ago in August 19, I did my experiment just before leaving to Hawaii. I had positive results, but we could see the balance wobbling above the line. Now I'm reversing the current, so now I'm gonna show you what happens. So share screen, desktop.
That's right. Yeah, it has been a month, hasn't it? I'm right there with you. So that's the gallium, right? That's the gallium fluid where you're running an MHD current through it.
Yeah, the MHD Vortex. So this is tonight's experiment. Actually, I upgraded the wires.
Phil, can you paste links to your YouTube channel? Can you paste that into chat?
Yeah, I'll do
what?
that.
Let me do that.
It's a Phil Bouchard 8, the username. PBOUCHARD 8.
Let me see if I can find it. There we go. I'm going to email this to myself.
Yeah, so all my updates, I post all my updates there. And tomorrow I'm gonna do another one to my associate, my buddy, he told me to add a longer arm to the balance, so it's gonna be even more precise. We'll see even more precisely the gravitational weight change. And that's gonna be, I'll do that tomorrow, but tonight I'm just following up to my experiment. And so that's my apparatus. I upgraded the wires. It's gauge 4 now. I changed the ring, the middle ring for zirconium, because they're not affected by a magnetic field. So it's still conductor, but they're not affected by a magnetic field. So I added a little ball and a marble in it to show the speed of the experiment. So now if I go back, that was the presentation of and now here we see the gravitational weight shift. So now we see it's wobbling below the line. So the current is reversed. The current is around 66.5 amps, and we see what is that? We see the current being reversed. So that's tomorrow. I'm gonna. Oh, geez. Too many ads here on YouTube. So tomorrow I'm gonna add a more precise balance. I'm gonna extend the arm of the balance. So we're gonna see more precisely the difference in the gravitational weight shift. So so yeah, that was my update. I wanted to also regarding my book. Regarding my book, I know exactly that there's one little problem in my previous book. It's the fudge factor of each galaxy, actually. But
to improve their hearing almost overnight.
sorry about that.
Did you know that hearing impairments have nothing to do with your ears? The ears are nothing more than a microphone.
Okay, sorry about that.
Okay. No, that's fine. That's fine. Yeah, that was super short. We shouldn't have any copyright issues.
Yeah. All right. Well, in my book, I fixed the little error. I was not considering the rotation, the angular velocity of the stars. It changes everything because you have an electron in motion will induce a magnetic field. A mass in motion will induce a time potential. And I was not considering the angular velocity, but it changes everything. I got the exact everything fits together. I got the correct numbers. So I'll update my book and I'll do an update at the next APEC conference, I guess, if it's updated on time. But I've got everything works, everything the puzzle fits together. So I'm really happy about that, and I'll update the U.S. military as well regarding that. So yeah, thanks. That was my quick update here, and
yeah, well, Phil, thank you, and again, everybody who is still on here, let's give Phil enormous applause.
Thanks.
And yeah, Phil, thank you. And yeah, it has been a month. You mentioned that you couldn't believe it was been a month, and I was like, the gallium experiment. That's right. Holy cow. So yeah, time flies, but it's been a busy summer. I think we're all kind of reeling from it, right?
Yeah, it's exhausting. All it look like a simple experiment, but there's a lot. I started in May, June, and I'm still not done. So it's very exhausting.
Yeah. 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 Well, we've got about 15 minutes, I think, probably until the top of the hour. Why don't we, do you guys want to close things off now? I think we have a little bit more. Why don't we see if we can't keep going until 8? Rick, you had a question, sir? You have your hand up?
Yeah. Well, no, I just wanted to you go back to what you were talking about earlier about exoplanets and life and stuff like that.
Oh yeah.
About the difficulty in starting a civilization if you don't have oxygen, if you're non-carbon, non-water based solvent, but methane or something like that, or formamide or sulfuric acid or some other exotic chemistry of life, right? If you don't have oxygen in the atmosphere to burn things, we got our civilization from fire, right? From the development of fire, and then we went to the Bronze Age and developed all this technology. It would seem that it would be more likely that civilization would arise from a technical civilization would arise from an oxygen breathing water solvent type carbon.
Yeah.
But not rule out the possibility of other developing it, but because of the fire issue.
Well, you have electricity everywhere, even where there's no fire.
The thing that complicates this that I think none of us are, there's what we know in our heads, and then there's the intuitive aspect. And I think intuitively, I think there are a lot of complications. Like one of those, Kevin Newth had talked about this a while ago. He said that based on his statistics, and he's just kind of shooting from the hip, but his interpretation of the Drake equation, ET should have found us like 400,000 years ago, right? Just basically passing through, you know, kind of like Star Trek, except they stumble on the dinosaurs. And so one of the things that intuitively we forget is the scale of time, right? So the universe is like what, almost 14 billion years old. The Earth is about 4 billion years old. So we're pretty late to the game. And then even in terms of that 4 billion years, you had stop and starts and major cataclysms and dinosaurs and stuff like that. So it's entirely, I would say it's entirely possible that even in the Milky Way, we're looking at second or third generations, you know? So Rick, what you're talking about makes perfect sense. But then the thing to consider is like life, that life may have evolved and taken 3 times as long to get there, but it may have like moved worlds and had robots and, you know what I mean? There's this massive span of time before you get to us.
That raises a question about intelligence because like how much more intelligent, like if you were an octopus living in an ocean, right? Because we have a creatures on Earth that are as intelligent as humans, giant cephalopods. They beat the chimps in every IQ test. I saw this documentary called The Amazing Giant Octopus and showed that it was really intelligent. But I was thinking about this, like if you were a Cthulhu or an alien underwater on another planet, in order to make fire, you would have to be smart enough to evacuate a chamber of water, create an airtight chamber, and then create fire inside of that. That would be you could overcome it. It would just be an additional hurdle. It would take longer.
In theory, the octopus could have got here in a frozen block of ice. You know?
Well, that's, you know, I read a thing at one of the zoos. This is true story. They supposedly an octopus broke out of its tank. Somehow it managed to unfasten a catch, crawled out the top, slithered across the floor, and went down a drain pipe. From when they, you know, where they wash down the aquarium, they have a drain that goes out to the ocean.
Yeah,
that's
they did that. Yeah,
that's creepy. Yeah,
that's how most humans escape prisons.
That's a little bit too smart, you know. So probably shouldn't be in the fish tank if it can break out. That's my thought.
Well, one of the things that we're saying in the octopus video is that one of the reasons why what's stopping them is the mothers die too young, and so they can't teach the young. But there's an ecosystem in the Mediterranean somewhere where they're actually starting to teach each other and pass on knowledge. So, you know, that was the hurdle blocking them. But pressures in the environment were causing some of these giant cephalopods to actually start to transmit. So they're at the beginning stages of where they could develop civilization or something like that.
Interesting. So that's how it ends. That's how it ends. That's another movie plot. See, we've been waiting for ET, and the entire time it's giant octopuses. They're going to take us out.
Well, they say the octopus is from space. It came here in a block of ice.
Yeah, I've heard that, Mike. I know what you're talking about. Yeah,
that's the theory.
That's one idea, and it had to do with the DNA too, I think, or something like that.
Yeah, first that high intelligence, then they look at the DNA after that and say something's not right here.
Yeah, very, very intelligent creatures.
If the octopus could have done it, what else, you know?
Doesn't have to be the end of us, though. It doesn't have to be us versus them, zero-sum game competition. It could be win-win where we work together, you know, mutually to build each other up. It could be like that, you know, open system.
I'm not pessimistic. Like I know John is a little pessimistic,
like,
you
know,
the
water bear
presents, but I'm really optimistic. I'm really optimistic. And then the other thing I've read a lot of nanotech and stuff like that, and there are a lot of books out there you guys are probably familiar with, stuff like The End of Scarcity. It's a post-scarcity society. A lot of the problems that we have in our world, they come out of like tribalism, right, which is a primate thing. They come out of scarcity, which is our economic model, you know. So you go to these potential ET civilizations and you don't run into those things as much, right? I mean, they're going to be post scarcity. They're not going to be fighting over money. It would
absolutely,
yeah, you know,
agree 100%.
Yeah.
That's not talked about so much in the ET. You know, it's always assumed that they're an enemy or they're hostile. And I'm like, no. If they were hostile, if they were coming here, they could have done something to us already. Would have wiped us out already.
We act and we react. There's this article online now about They're calling it a hypersonic missile gap, right? Because Russia has hypersonic missiles, so we got to have them. And I just read that and I was like, really? I was like, it's keeping up with the Joneses. And then when we have them, they need something better. I was like, it never ends. I was like, at some point, we'll be able to kind of put that aside, because it's just tribal stuff, really,
Yeah.
But,
and then most fights are over scarcity issues too. Like, so if we were to go interstellar, we would have a lot more real estate. There'd be a lot less fighting over land, or you know what I mean. It would be an open system with infinite resources. It would bring a lot of peace to human civilization in a lot of ways, I think.
Yeah, I think especially in Earth, because Earth would be so important to so many people who weren't on it, right? So, yeah. Yeah, well, guys, we're about 5 minutes out from the top of the hour. Does anybody have any closing thoughts? I think this has been one heck of a conference. I'm going to take this Zoom up. I have to trim the front, and then I'll upload this thing, so it should be up in the next day or so, or less, probably up by tomorrow morning.
Thank you very much.
Oh, yeah. Well, Rick, thank you, and welcome. Welcome. And again, tell your friends. Try and get folks involved with it, I mean, it's a community effort, right? And it has been from day one. So.
All right. Thanks, Tim.
Yeah. Well, thank you, Curtis, and Phil. Thank you. And Brian, thank you for the tremendous presentation. You guys are all looking a little tired. So, but this has been.
So sorry, are you I know initially it was going to be bound, like the time frame would the APEC would be time and stop in this fall, but are you planning to be ongoing for a longer period of time?
Yeah. No, it's booked through this fall, but what I'm trying to do now is book people about, like, in terms of those structured events where we're using StreamYard and we've got folks who are doing structured presentations, right? For those, I'm trying to stay about 2 months ahead. And part of that is because I got change. I mean, I've had 2 people who want to do it and 2 people who are like, I can't do that day. And so I keep changing things around, and it makes it, because I keep updating pages and graphics and all that stuff. So,
other than APEC, I see you're doing a lot of interviews outside of anti-gravity as well on LinkedIn.
Yeah.
You're full-time.
Well,
interview.
just community building stuff. So, okay, well, guys, I'm going to close things down for today, but it has been an absolutely wonderful conference. It is September 16th.
Where will this be available to watch, or where will this be uploaded?
It should be up by tomorrow. It'll be on the Alt Propulsion YouTube page. That's where we're putting. Yeah. Okay. Well, so it's September 16th, and this has been APEC, guys, and have a wonderful, wonderful weekend, everybody. Thank you again. Thank you so much.
Thank you, Tim.
Thank you.